Okay, so thank you for joining us for our webinar this morning. It is the last in our three-part series that we are offering this year in 2026. So this is the City of Seattle hosted Integrated Pest Management and Recertification webinar. My name is Kate Kurtz. I use she, her pronouns, and I will be the facilitator for the webinar today. A little bit about me, I'm the Organics and Sustainable Landscape Education Program Lead for Seattle Public Utilities, and I'm just one of several members of the IPM Webinar Planning Committee. So that's just to say there's a whole team of us who are behind today's production. Before we kick off today, and introduce our new speaker, I would first like to acknowledge that we are on the ancestral lands and waters of the Coast Salish people, who of course are still here and have stewarded these lands since time immemorial. I'd like to say thank you as our hosts before beginning this event today. Thank you. Okay, at this point now I am going to introduce our first speaker. We're now going to hear from Glenn Kohler from Washington Department of Natural Resources regarding the connection between climate change, drought stress, and opportunistic insect attacks on forests here in Western Washington. Glenn, you can go ahead and start sharing your slides.
Okay. Morning, everyone. Thanks.
While you're doing that,
Yep.
I'm gonna tell the audience a little bit about you. So Glenn is a forest entomologist with the Washington Department of Natural Resources. He received his master's degree from Oregon State University, where he worked on biological control of hemlock woolly adelgid. How do you pronounce that, Glenn?
Adelgid. Adelgid. That's a tricky
Adelgid.
one.
Thank you. Didn't nail that one. In his role at DNR, Glenn assists private landowners and state land managers with forest insect concerns. He also conducts annual monitoring of forest insect and disease conditions throughout Washington state. Glenn, thank you so much for joining us today and presenting.
Yeah, thanks for that introduction. Appreciate it. So I'm gonna go ahead and get started. I would like to add, so in my bio, it's state and private essentially are most of our clients, but also we have at DNR urban forestry program that many of you are probably familiar with already. I'm representing the bug side of things, the entomology. We also have a couple of pathologists who are looking at tree diseases like root rots, foliar diseases, and we're a resource for you. Not so it's also communities and cities, not just forest landowners. So we are servicing the urban forests. And sometimes if the UCF people have tricky questions about bugs or crud, they will contact us. And I've done some work recently with the City of Seattle on Ips pine engraver, the new California five-spined Ips that I'll talk a little bit about today, that's been killing some pine trees around the Puget Sound. But these are the kind of things our program does. We work statewide. We're based in Olympia. We do have one entomologist in Northeast Washington, Colville. We have some annual monitoring that we do regularly, an aerial survey where we map all the forested acres of the state every year from an airplane, looking for dead and damaged trees. Unfortunately, those maps don't cover large urban areas due to airspace issues with airports conflicting and also just not as many trees. It's harder to map from the air in a city environment. So we don't have good coverage of the Seattle Metro on that survey. We also do some ground trapping for defoliators like Douglas fir tussock moth, stream baiting for sudden oak death. But then on the research side, every once in a while we get these new events that come up and we don't really know what's causing the mortality or dieback, and we will go out and just for a year or two put in some plots or traps and try to assess what might be causing these issues. And some recent examples are sooty bark disease in maple. I think that's what that picture is showing, the purple plots for the maple. I mentioned California five-spined Ips, just kind of one-off projects. And then, of course, we do the tech and outreach, tech assist and outreach and education like today. So thank you all for adding a couple hundred people to our list of contacts to accomplish our grant deliverables. Um, so thank you for being here. If you have any questions about, what's going on the last decade anywhere in Washington, forest health wise, these forest health highlights reports are a great resource for that. These are easy to find online just by searching forest health highlights. Most of the Western states will produce these, and a lot of it is trend information based on our aerial survey, but also in the back pages, there's contact information for our program. If you remember, oh, I did this webinar and I can't remember the guy's name and I have this weird bug. If you can remember highlights report, you can find our contact info in here. And there's lots of web pages listed and ways to get data and maps and that kind of thing. And also look to WSU Extension. Folks are a great resource for information for you about new problems. So I'm going to focus on drought, uh, extreme heat, and we all know that recently these two factors have been a real drain on our forest health. It varies across the landscape. Some places are hit harder than others, but certainly in an urban environment where you have a lot of parking lots, pavement, that kind of thing. Um, Trees are more exposed to that southwest facing sunlight. And if you were around in 2021 in Western Washington for the infamous heat dome, was just brutal heat in mid-June, I believe it was. And trees in Western Washington are not ready for that level of heat at that time of year. And really the temperatures that it got up to probably wouldn't have been ready even in the middle of the summer. So we did notice this kind of scorching. It doesn't show up great in this photo, but this poor hemlock, most of the new foliage out on the tips here is kind of this tan brown color. And it really did look like if you're driving around, again, some of these roadsides, south facing, trees just look like they'd been burned in a fire. Um, there wasn't a lot of mortality as a result of that, but there was some branch dieback, tip dieback, and certainly a lot of stress on these trees. The heat itself killing buds, and so that was a really unusual event, um, not really recorded in my almost 20 years with DNR. That kind of tree damage. What we normally see are drought effects, and drought being a lack of water. So that's one thing. But then when you add on top of that these extreme temperatures, we're calling it hot drought. And this is a term that's been used in peer-reviewed publications at this point. Hot drought just meaning that already with limited water, you add the heat, just cooking the water, desiccating those needles or leaves, pulling the water right out of them faster due to the heat. Excuse me. Um, so that just it's kind of like a 1-2 punch for these trees. That's not good in any way. Um, so with climate change trends, and I'll show some pictures of what it's looked like in the last 25 years. We're seeing a real measurable uptick in the intensity of the droughts and the intensity of these heat events. And so in Western Washington, extreme temperatures are basically anything over 90 Fahrenheit. And the number of days we get over 90 Fahrenheit each year seems to be just increasing. And then also the length of the season that we're experiencing those temperatures is extending. So happening earlier in June and staying hot later into September like last year. So I mentioned that effects are really variable, and of course, like if you this picture here from the Columbia Gorge, oaks and ponderosa pine, like on a ridge top, this is a pretty harsh site. And there are places like that in Western Washington where like Mason County and places where you've got a lot of really rocky soils and well drained and droughty sites. So it's just going to depend on where your trees are at. They might be more sheltered. So this is a nice long list of the different factors on your site, and different weather events that are happening that can really impact how a tree responds to drought. And some trees, even trees of the same species, so take Western red cedar as a good example. um, I'm sure you've all seen some dieback effects in Western red cedar recently. And you may notice that you can find a dead top cedar or a cedar that's completely died, and the tree next to it, another cedar, lives fine. Um, and so that's probably due to tree size and the soil, differences that one tree is growing in. Just those little microclimate differences can be enough, and also genetics can play a role. But also the last thing that I'm talking about is these opportunistic insect and disease attacks, essentially. These drought stress trees are much more susceptible to that. And so, speaking just about insects today, they can be really targeted. And some insects will use pheromones to draw in their friends and neighbors, family members, whatever you want to call it, and mass attack a tree in high numbers. And so that may be another reason why that one cedar is dead and its neighbor is not, is the bark beetles or whatever killed it off, focused on that one tree and left the other one alone. So it's very variable, highly variable. Um, so you can get, just from drought alone, I'm sure you've all seen things like this. You can get completely dead, usually reproduction size trees planted, young seedlings will die straight up just from drought. Um, what's more common in the bigger trees is this branch flagging pattern, dead tops, and you may go in and say, again, this is another picture from the gorge on the left here. You got ponderosa pine, Douglas fir, and one thing you might notice with drought effects is it's often more than one species. So if it was a bark beetle just on its own, or a root rot on its own, those pests tend to be really host specific, right? So pine beetle wouldn't attack the Doug fir. Doug fir beetle wouldn't attack the pine. So that concept. So you can see this effect across different species. And so you might go in there and look, okay, these trees, to me in this photo anyway, on the left look dead, or nearly dead. And you can go in and examine the foliage. And what I do, or advise people to do, is look at the buds. If you have a lot of brown foliage, sometimes it could be weather related, not just drought, but also winter damage, or desiccating winds. There's a whole bunch of things, foliar diseases that can turn foliage brown. But if the buds are green and juicy, healthy looking, pull them apart, they're green inside, that tree's likely to recover. Those trees aren't dead, in fact. But you could look around in there and say, okay, I think this tree is completely dead. Then what I advise people to do is remove some bark. If they think it might be bark beetles, looking for the galleries that help us identify what species bark beetle. So what happens a lot these days is we'll remove bark, like in this center photo, and there's no galleries, no evidence of even wood borers, which are really a whole bunch of different, usually beetle species, longhorn wood borers, metallic wood borers, that just attack dead trees. We're not even seeing evidence of that, because oftentimes the the inner bark, where all the sugar is, the phloem layer that the wood borers are interested in, the bark beetles feed on that layer. That's so dry in a severely drought stressed tree that they don't even take an interest in that. Um, so you kind of have to find this sweet spot for the bark beetles, where the tree is stressed enough that its defenses are neutralized. It doesn't have a lot of pitch flow response, which is the first line of defense for a tree. After the bark, the beetles get through the bark, then they get pitched out by a healthy tree. But if the tree is so drought stressed, or burned in a fire super severely, the beetles don't use those trees typically. So more direct effects, you could have stress cone crops along with the dead top. Sometimes that's associated with root disease. If you get direct sun on the stem of young trees, that really tender bark can get sunburned literally, and then you can get fungus come in and cause these stem cankers. And then just things you would obviously expect with any drought stress plant, the wilting. You're probably not going to see the wilting unless you're out there the day that the heat event is happening. Most of the time, what you're going to see is the brown, scorched looking needles or leaves. Okay, so here's the depressing 25-year chart from the U.S. Drought Monitor for the whole state of Washington. I will say at the top here, drought is normal. Um, all of our native tree species are adapted to at least 3 months of the summer with almost no rain in Washington. And a lot of people who've never lived in Washington, they think we're always soaked to the bone, and it's our little secret that Seattle is sunny and beautiful in the summertime. Anyway, notice the duration of these droughts, and so between each, January, we've got a full year. And some of these years where you just get a few months, that's kind of the normal condition I'm talking about. That's not going to be a big deal for our trees. When these colors reach the top of the chart, that's 100% of the state is involved in some um, drought condition. So that would be the maps here, 2015 and 2021. Literally every acre is affected at some level. So it gets to the top of that chart. So then we start to look at 2015. If you were around then, that's in recent memory the worst drought. We had some really horrible wildfires that year, and that picture at the front of my show with all the little Doug firs that were all dead, that was along Highway 18 heading up to Tiger Mountain in 2015. Just tons of little trees died that year because in the 15 years before that, things were looking pretty good for them, generally speaking. And then what the heck? Uh, I'm not ready for this. And so then 2021, and unfortunately, just last year were some more either extreme or exceptional drought conditions. We usually get off a little easier on the west side. Um, but the other thing to point out here is the duration. Um, so, I mentioned this summer drought being a normal thing. Since 2018, we've basically had no break all year long. So this is not good. For just looking at last year specifically, another bad drought year. So, West Slopes, Cascades, Puget Sound, uh, moderate to severe. So just remember that even that orange in the middle is severe. So this is not a good condition. Um, and then these are departures from normal. The top being precipitation. Um, Normal is 0 in the middle, and we get a big dump of rain in December that, you know, landslides last year were terrible, flooding. Um, but then notice the temperatures on top of that. We had lower than normal rain during the spring and summer, and then temperatures above normal the entire time. And even getting into, again, September being 5 degrees above normal. That's normal for the last 30 years on those charts. Um, so that's where we are. Another year of hot drought. Um, okay, so on to the insects, and I will mention that most of what I deal with in my job and help people with are native pathogens and insects. We do have some invasives that are established in Washington. Um, and I'm not going to talk about those today, but there's some non-natives like spongy moth that the State Department of Ag is doing a great job of keeping at bay, so that we don't have spongy moth outbreaks like on the East Coast. Other things like I'm trying to think of the best example that probably white pine blister rust might be one that you're more familiar with. That's in the white pines of Washington. It's a canker-causing fungus that's from Europe that's been here for over 100 years. It's capable of killing white pines. So that's something that's everywhere, and we just kind of manage around it. But for the most part, most of these things that we consider pests are native, and our trees are adapted to dealing with that. And so at low levels, the quote unquote pests aren't really a problem. They're providing ecosystem services. So the bark beetles are, and wood borers, like in the cartoon there, really good at starting the decay process of a downed tree or even branches. And so they go in that dead stuff, they breed in it, they do really well. And the vast majority of them are going to come out again in low numbers and go back into other dead things. But if you get in a situation where, like with the pickup truck photo there, you've just got a ton of wind thrown or winter storm damaged trees that all died at once. It's just a huge load of breeding material. And so we can get certain insects will have outbreaks coming out of that down stuff. So usually when we have outbreaks in the west on the west side, it's some major disturbance, often windstorms, but drought is a big disturbance. Um, so we can get higher levels of things like these secondary insects I'm going to talk about today. So I use the example here of Douglas fir beetle, um, and that's the case in this upper right photo. That's Douglas fir, large trees. This is prime habitat for a Doug fir beetle outbreak. And so that was DNR land and some private timber company land up there, and they did a lot of salvage to remove that stuff to prevent the outbreak. So that's what we would consider a primary tree killer, where if populations are high enough, Doug fir beetle can easily kill healthy trees, even in a non-drought year, be because of the high numbers of beetles. Um, so that's not what I'm focusing on today. I'm going to focus on these other disturbances that create what we call secondary insects. So Doug fir beetle is a primary, and I'll talk about secondary today. Um, Maybe you've seen the Mannion death spiral. I'm not sure if Mannion, who published this originally, appreciates it being called death spiral, but that's what I'm calling it. So this is just a think of it as sort of like the toilet, circling the toilet bowl as a tree is going down and about to die. The predisposing factors or the outer ring here, um, and some of the ones I'm talking about are pointing out climate change driving low soil moisture holding capacities. That's a site factor. Climate change can, kind of get worse and better as we go through. And then trees that are planted or growing outside of their climate adapted range. So off-site trees, um, a lot of trees that are planted on poor sites could fall into that category maybe. Then the inciting factor, they have several on this chart here, but I'm just going to focus on drought being so essentially predisposing factors are just there in the background. They're kind of always there. Um, and then we have an event that comes along, um, like defoliating insects is one example on there. Tent caterpillar outbreak or something weakens the tree. So drought is this event. It doesn't happen every year. So that weakens the tree further, and then the thing that actually kills the tree, sometimes that could be drought itself, as I said, but often it's insects or diseases, and those are the contributing factors that kind of nail in the coffin. Um, so when minor pests can kill, that's kind of where we're at these days. So I mentioned call them secondary often, and a phrase that gets kicked around a lot these days is rise of the secondaries. Um, Titled my talk that because what we're seeing is some of these diseases, insects that are less important, usually historically in the literature, we're not seeing much evidence of past outbreaks. People didn't take notice that are suddenly becoming more aggressive. Um, or our trees are just more susceptible. So that could be spreading more. Um, and who's next? It's a open question of we don't know what insect or disease is going to fill the next void, um, and take over a new kind of niche in these distressed trees. So some recent examples that we got some funding to do was California five-spine ips, trap monitoring in the pines, and we got some funding to support some WSU research looking into the link between drought stress and the rise of this Ips pine engraver. Um, and early data, they're doing some tree ring analysis, and it shows that the trees that were killed compared to trees that survived this outbreak, the killed trees had um, smaller growth rings, were slowing down from drought. And sooty bark disease, there's some discussion about that fungus being native or not native, and um, but essentially it just was unheard of before and has become kind of rampant in mostly maples that are dying from drought and other causes. So this is just one example in young. If you got some planted Doug fir of this size in the picture here, or even young seedlings, this is really common. It's been around forever. Another native, it's not a bark beetle, it's a weevil. Although somebody decided to put the bark beetles in the weevil family a few years back, and so here we are. Yeah, these cute little guys are loving drilling into little thin twigs and laying eggs, and then their grubs or larvae feed in the pith and kill the branch tips and tops. And so this is really associated with drought. And so I've been getting more reports of this thing recently in plantations. This is another one that isn't really going to be an issue in Western Washington like right now. I've seen one tree with this on the west side, but more and more I'm seeing in Eastern Washington, and it's a huge problem in Southwest Oregon. So down by, Grants Pass, Ashland, that area. Um, it's a Doug fir pest, the flat-headed fir borer. It's one of the metallic wood borers that have this kind of, football shape, adult, often shiny metallic green. You've probably seen those. This one's pretty small. The adult is only about, I'm going to go with half an inch. And um, what what we're seeing, to like I said before, having these kind of wood borers in a dead tree is totally normal. You'll see it pretty much in every dead tree. But a couple weird things here. Be on the lookout for this if you see it, because I know you might have some sites where you've got Doug fir being the main host for this guy on a really crummy site. And Doug fir on that site may be having a really hard time, more exposed to the sun, heat. These beetles love the heat and open stands. You can see these trees affected in the picture here have more open growth. Um, and in fact, they'll preferentially attack like the south side of the main stem because of the heat. And what's unusual is the woodpeckers will come and flake the outer bark off. So that's what's going on here. Um, and not necessarily making holes like woodpeckers usually do. And because these beetles will go into the outer bark, and the woodpeckers can just get them out that way. So you can kind of see this like naked bark effect here. And then the tree is still sort of green. It's, got green needles still. It's not completely dead. To have wood borers making these tracks in the inner bark as larvae in a live tree, super unusual. That's very much bark beetle behavior. So they kind of do act like a bark beetle in Southwest Oregon. Um, if if you've had these, you'll see these little oval shaped exit holes, tiny 1/4 inch wide exit holes. Again, not unusual to see in a dead Doug fir. Um, but if you do see something like this and the tree has still got green needles on it, it'd be interesting, something to report. But perhaps one of those things that on the horizon in 20, 30 years going to become more important here. Okay, so talked a lot about bark beetles in general. What are they? What do they do? If you don't already know, these are the basics. They kill trees within a matter of weeks, hundreds, thousands of larvae feeding in that phloem layer, cut off the flow of sugar to the roots, and the tree dies rapidly. Then, just like with a flood or anything like that, a tree that's killed quickly will turn completely red, orange, whatever color you want to use. All at once, all the foliage will turn the red dead stage. And sometimes we don't see that until the year after the beetles killed it, unless it's a really hot year. So they locate trees through volatiles. Of a dying tree will make ethanol and terpene smells that, it's just like the Christmas tree, pine, pine scent. We like it too. They follow that. They find a dead tree. But then if it's a live tree they're trying to get into and there's enough beetles around, they can coordinate these mass attacks with a pheromone that's specific to that species. Uh, and it's important to point out that the bark beetles only use a tree for one season. Once they've killed it, a ton of other wood borers will come in. Lots of other kinds of insects and fungi will come in. But the bark beetles, once they've left the tree, they're not going to hit it again. So if you see these exit holes, uh, really tiny usually, they're going to be perfectly round. So it's just the cross section of an adult beetle coming out, and they're deep. They go all the way into the sapwood. And so if you look at Doug fir bark, any Doug fir, go out in the parking lot and you'll see little holes in the bark. It's very common. Take a pocket knife and shave those holes back, kind of follow back into the bark, and they'll disappear. If it's bark beetles, you could literally take like a paper clip, unbent paper clip, and stick it in these holes, go deep in. And usually they're in little clusters like this. But if you see those exit holes, then, that tree is a hazard for falling, eventually going to rot and die. I mean, rot and fall over. It's already dead. But if it's out in a wild area, it could be a wildlife tree. It's not going to produce any new beetles. It can be left in place. So the bark beetle life cycle, pretty simple. Just to point out that the only stage that leaves the tree is the adult. And so spending your whole life, or your whole adolescent life anyway, in the darkness and sticky sap. This is bark beetle's life. So the adults are the only stage. They exit the tree through those holes, fly, find more trees, lay more eggs. Most of the major pests are a year life cycle. So you have more time to respond to down trees that are breeding in. But some of them, like the pine engraver, life cycle is really fast, just a couple months, and they can do 2 to 3 per year. So breed up rather fast. We identify bark beetles by using the gallery patterns. Sometimes on the external bark, we'll see pitch tubes, pitch flow from many points on the tree, and sometimes frass or boring dust, little piles, usually always red or brown. And the pattern of these galleries can be used to identify which bark beetle you have. Okay, so secondary bark beetles. I'm going to talk about Douglas fir specifically here. They breed in these small branches and slash that are basically everywhere, even if you're not doing any logging or thinning, and they just stay in that stuff. That's what they do. They're not aggressive. They act as thinning agents for weaker trees in the understory, like this crowded stand here. These trees that are suppressed and dying often have these secondary beetles in them. So they're usually good guys, but when we combine that drought event with a lot of breeding material, sometimes we can get outbreaks of these. And that's been happening off and on for the last decade in Douglas fir. The gallery pattern on these two, you're not really going to be able to tell the galleries apart that much. It's just 2-3 inches long. The egg gallery is made by the adult female, and then the larvae mine off after they hatch out from the eggs. So virtually similar, identical gallery. They're going to be in small branches, small tops, young trees. Um, but this is the one that will do a lot of top kill and branch flagging. There's actually 3 different species of these, and it doesn't really matter which one you have. It's just I can almost guarantee you if you cut down this Doug fir on the right here, those beetles would one of those species would be in that top. So from a distance, you can kind of get this like dirty brown green look if that's showing up on your screen here. Much more common on the east side, being droughtier, but we've definitely seen some of this around the west side. So this one is it's kind of secondary, but when it switches into outbreak mode, it's much more aggressive than say the secondary is in Doug fir. And fortunately in Western Washington we don't have a ton of pine, and I haven't seen this. Like shore pine is probably the most common um, in Western Washington as far as like natural forests go. And I haven't seen it. We've seen it in shore pine along I-5 um, recently, but those are just really stressy situations, right? But out in the woods with shore pine, haven't seen this really in an outbreak condition yet. In fact, we haven't seen any wildland pines with this beetle on the west side killed, except for one place, which is Fort Lewis, JBLM, which has a native stand of west side ponderosa, which is really cool. Um, Kind of like an island of it almost looks like Eastern Washington in there. And they did have an outbreak of this beetle there, which was kind of alarming, and then disappeared, thankfully. So some background, it's a pine engraver beetle. We have another species that's Ips pinei. This one's Ips paraconfusus. Ips pinei is super common everywhere in Western Washington. Major management problem on the east side. Um, so historically, as the name suggests, California, Oregon being the native range, um, they breed in anything over 3-inch diameter, so they can get in really small stuff and reproduce in high numbers. And then I mentioned the 2 to 3 generations per year, population build up rapidly. And then if we have a drought on top of that, the damage that they do is often much, much worse. And so what you'll see for damage is a top kill is a real common thing because they like the smaller size stems. Um, but what I've seen around Puget Sound with this thing is the whole tree dies. Um, Unfortunately, I think our trees aren't as adapted to this species because it's kind of new. So there's the range of Ips paraconfusus conveniently stopping at the Columbia River there, and not recorded in Washington. We looked at museum specimens, 4 different collections, couldn't find any. So 2010, um, and you can see that's Hood River. Looking from Hood River into Washington, white salmon, um, tons of ponderosa killed, just alarming numbers from this thing. Outbreaks went on for I don't know 6-7 years, kind of unusual for this beetle. So at that time, 2010, 2011, we started trapping, like, where is this in Washington? And over that, we didn't trap every single year, but that's, I don't know, 12 years of trapping. It was probably actually 10. All of the red squares on this map are where we found at least one adult in our traps. Um, so California five-spined Ips's range is really increased all the way up into Snohomish County and as far east as Walla Walla. Um, as far as trees killed goes, it's pretty much been restricted to a ton of activity in this Skamania, Klickitat, Columbia Gorge area. And then all these blue um, circles here are where we have collected them from pine trees in Puget Sound. Um, so that event, when we were trapping for this thing, at one point the farthest north was Fort Lewis, and we caught 3 adults in one summer. And now, if I put a trap out there, I would catch thousands. Um, so it's obviously changing. The situation's changing, and the kind of purple dots that are all over the place here, that's the Ips pinei that we mapped in aerial survey. But as far as Eastern Washington goes, we haven't seen mortality from this thing really outside the gorge, thankfully. But lots of, Puget Sound, look out for, Austrian pine. I mentioned shore pine, Western white pine. This thing kills them all, and thankfully it's just appears to be restricted to drought stress trees and the Puget Sound event. Um, so seeing dead trees really 2022 to 2024. Those were the 3 years where this was the worst in the Puget Sound. And we think that might have been linked to the heat dome. At least the timing was right for that. Um, so I'm not going to spend a lot of time on managing for this because it's really an east side thing. And it's kind of complicated to get your head around, like, oh, when do I time, my harvest and slash, and I don't want these beetles to breed. It's like a big deal on the east side. Every timber sale project, every thinning project will have some kind of slash management component. So I'm not going to go into that, but I will say, just keep in mind that if you are doing any thinning or pruning work in pine specifically, don't worry about Doug fir or other firs, just pines. Uh, Keep in mind that if you leave stuff lying around like this in the late winter, spring months, where it says risky there, um, that you could have this beetle breeding in this stuff. So just keep in mind, chip that up, um, whatever you can do to get it out of there, or do your work in the fall. Um, okay, so I got about 10 minutes left, I think. Uh, yeah, close. So I'm not sure. I just am going to annoy you guys and go through. Okay, I just want to know where I'm at. I'm good. We're gonna make it through all these slides. I can't believe it. Okay, so fur engraver. This is it sounds like the Doug fur engraver that I talked about earlier. It's a very confusing name that way. Um, so this is just fur engraver. Leave the Doug off, and its main host around here is going to be grand fir in the woods, and that occurs all over the west side. Um, and so what you're going to see in the urban environment, though, suburban environment, is maybe a lot of Fraser firs and noble firs, and people love to plant their Christmas trees. Um, if they had one in a pot, they put it out in the yard, and you all know how well these ABs off-site trees do. I've got one in my neighborhood that's probably 120 feet tall, like a noble fir or something. It's got two stems, and it just looks terrible, but it's never going to die. It just sits there. Uh, anyway, um, that could get, at the beginning, uh, we talked about adelgid. I worked on hemlock woolly adelgid in grad school. We have the balsam woolly adelgid, uh, is a non-native insect. It's like they're like aphids. They make these little white cotton balls on the bark, and that's another really common thing that might attack these off-site ABs trees is balsam woolly adelgid. Uh, and then you could get this fir engraver could come in and finish those trees off. Anyway, I put fir engraver in here because it's kind of a secondary um, in the way that it follows drought or stress from defoliators or sucking insects like the adelgid. It's unusual for a bark beetle. The egg gallery goes across the grain. So if this tree was standing and you took the bark off, the egg gallery the adult female makes would be parallel to the ground, and then the larvae going up and down. And if you see adults, whoops, sorry about that. If you see adults, this is the head and the pronotum, like the thorax cover there, wing covers, rear end looks like something took a bite out of the rear end of it, and its wing covers are flat. Let's see, I just went to the next slide. Yeah, same picture, next slide. And there you can see those transverse galleries that are parallel to the ground, and that's a real um, slam dunk for identifying this. Anyway, fir engraver is a huge deal on the east side. There was hundreds of thousands of acres of fir engraver mortality in grand fir, and white fir in Oregon and Washington the last few years. Our peak was 2019. The bars are acres of aerial survey. We almost hit 165,000 acres. But it does occur on the west side, and it does follow drought. So you can see, ignore this line here is how many acres we surveyed in total, just to give you an idea of, like last year, we only did 75% of the normal survey area. And so this decrease from 24 to 25, some of that's due to us surveying less. But you can see this general pattern. So 2015, horrible drought year, up, up, up. 2020, COVID, we couldn't survey that year. 2021, another terrible drought, up, up, up. And so I would expect that, again, if we could survey the whole state, we're having issues with our partners at the Forest Service right now to complete this. I would expect that to start going up again. And that's there's the reason for that delay is partly due to the trees have to build up some cumulative stress to get to the point where they finally die. So it can take a few years after the drought. And then when, like I mentioned, the beetles kill the tree, it doesn't turn red until the next year after it's killed, and that's the year we map it. And so there's often a 2-3 year delay between a disturbance event like a drought or fire before we see the full effect coming into the data. So the reason it's fern engraver is kind of a secondary is it doesn't really use a pheromone, so to attract other beetles. All it's doing is following those host volatiles, the smell of dead and dying trees. And so the attacks tend to be fairly random and really, really heavily associated with that predisposing drought. Some management advice here, removing wind throw, kind of like with the Doug fir beetle or the pine, want to get that larger pieces off the ground. So with Doug fir, true firs like ABs, it's the big pieces of wood that we're worried about with bark on, so 10 inches or bigger diameter. These guys could potentially breed in that. The term green attacked trees is referring to, and you'll see this with any bark beetle, where I mentioned they're being killed, but the tree's still green. And so from a distance or just walking by, you wouldn't notice that the tree is dead, it's still green. But you would notice the pitch tubes or pitch streaming or piles of red frass. And that is a green attack tree, essentially probably still has the beetles in it. And so if you're doing some kind of removal to sanitize, remove some beetles, that's what you're trying to hit, is those green attack trees. If you're removing these red trees that have the exit holes, again, the beetles have left, all you're doing at that point is dealing with a hazard of a dead tree. You're not doing anything to reduce bark beetles by removing red trees, usually. Okay, so quickly, just an example of a decline complex. So you'll see this a lot in the literature. There was one a few years back called sudden aspen decline, or SAD, worst acronym ever. But it was SAD. And it's usually what researchers will stick a label on. They have no idea what's going on. So it's a complex interaction of biotic and abiotic factors. That quote actually appeared in somebody's doctoral thesis at one point. And I'm sure it shows up in lots of research papers. Complex interaction. It's basically what you say when you don't know. And so with the cedar I mentioned earlier, the dead tops are really common with cedar. We had that going on. We're like, hey, we have a decline complex. Like what complicated factors are working together to kill cedar? And so and when I say we, it was a lot of different people from WSU, from the Forest Service, from the states, put out a network of plots, even recruited public, citizen scientists to put in points where they saw this kind of damage in cedar, and that's you can see where most of that occurred. I think those are both the plots that had site data and just plots that had reports of dead trees. And then they did WSU researchers did some analysis on site factors and drought factors, and of course, no big surprise to anyone who knows about dead top cedar, which like if you drive up Snoqualmie, it's those candelabra cedar with multiple dead tops. Um, this kind of thing's been going on for since the beginning of time. Whenever cedars had started growing in Washington, we've had drought events, and they're really susceptible to drought. They are a moisture-loving tree. The tops die. The bottom of the tree recovers and puts up a new top. Hopefully, the whole tree doesn't die, which unfortunately some are. So, a big surprise. Research confirms drought is the main driver of that Western red cedar decline. And of course, as I mentioned before, there's always going to be some little bark beetle. There's 100 different species of bark beetles in Washington, minimum. Most of them are doing this kind of minor thing following, oh, here's a cedar that's basically dead. I'm going to go take advantage of that. So these little Phloiosinus beetles are not major pests. They're not aggressive. There's bark beetles like this in hemlocks. Pretty much any tree, hardwoods included, will have some kind of bark beetle. There's an alder bark beetle, a bark beetle in ash. They're very specific to those trees, and they're almost always only going in trees that are weakened by some factor. So external, if you see the tan, brown boring dust piling up, um, you don't even have to remove the bark necessarily to know that there's bark beetles in there. Okay, and in the 1 minute maybe I have left, just some management ideas. So this will go along with your IPM kind of thinking for your pesticide credits. Um, Increasing tree vigor, that's kind of a no-brainer that's going to work for drought concerns. And of course, I'm linking bark beetles and drought in this slide. Essentially the same management will work for both. So anything you can do to increase water, light, nutrient access for these trees. In again, high value trees, urban environments, you have the luxury of mulching and watering and that kind of stuff that we wouldn't have access to in a forest situation. Um, and the diameter growth that you're getting uh, indicates that a tree is happy, and usually putting on new rings in the main stem. Diameter growth is the last thing a tree is allocating resources to. So if you're getting good diameter growth, you're also getting good defensive capabilities. Those are correlated. So get these trees to grow faster. Thinning out competition, things you don't need, trees in the understory that aren't going to be part of the long-term plan could be removed. Looking at site factors with a forester, what could grow here? What are the drought tolerant species I could choose that are going to grow better here? Focusing on thinning from below to protect your dominant trees that are the more likely to do better in the long run. And then, of course, controlling those invasive species under the tree. Blackberry patches growing under a tree are just sucking a lot of the water up, and you don't want the blackberries, but they'll come anyway. And then planting native and drought tolerant. So these are all kind of no-brainers that you already know, that you're already doing. But if you're worried about these secondary bark beetles, the rise of the secondaries, that any one of these things can be utilized um, to reduce effects of those. Uh, and again, I'll just reemphasize that taking out the dead and the dying trees isn't really going to control the bark beetles. They're going to be around anyway. Um, but you have other reasons to take out dead and dying. Okay, I'm going to stop. And I think I had one more slide about more direct, how do we attack bark beetles with pesticides and things like that. I'll just leave this up while we're doing questions because I'm out of time.
Perfect. Thank you so much, Glenn.
Yeah, yeah,
Actually, we're gonna share the code word slide, but during Q&A, that would be a great time to bring this back
sure.
up.
Okay, so you want me to stop sharing?
Yeah.
Okay.
Perfect. Thank you.
Mm-hmm.
Yeah, thank you so much. That was very informative. And I love that you called watering and mulching our trees a luxury
It
because we
is.
don't a lot of times think about it in that fashion. Being in our urban environments, it's definitely um, something to something to see.
All right. Thanks again, Glenn. I took a lot of notes, and I'm sure a lot of other folks did as well. We have several questions in here. Um, Washington DNR Urban Forestry Program was on the chopping block. Is that something when the session was ending? Did the program survive, and is it included in the budget? Or could you have anything to share related to that budget?
Yeah, good news. I don't know all of the ins and outs of. I believe that they got more funding through the legislature than was expected, but I also know that the state has funding from other sources, and I was a little bit alarmed when I heard that too, and wanted to find out more because they are such a key component to what we're doing. And then with Emerald Ash Borer coming,
Yeah.
that they were going to be the main point of contact for people getting grants um, to do, to help with the removal costs and things like treatment costs.
Mm-hmm.
So without them, for many other reasons, that would have been very unfortunate. So as far as I know, they're good for the next biennium.
That's good. Good news.
Yes. Yeah.
Now the next question. I often encourage clients to leave woody debris in place on their urban properties. Given the risk of insect outbreaks that can result from high concentration of downed woody material, is there such a thing as leaving too much woody debris, or is the amount of material on the typical urban property not enough to throw conditions out of balance?
Yeah, you nailed it in your question. It's the amount.
Yeah.
It's really hard to gauge that sometimes. Um, but one study that was done in a natural forest setting was looking at Doug fir beetle and Doug fir on the ground, and they actually counted the number of beetles going in and the number of brood coming out. It's a really great study, and basically what that came up with was per acre, if you had 5 down trees, and these are big mature Doug fir, 5 per acre, that was enough to kill 2 standing trees per acre. So roughly half of the material down on the ground, equivalent to live trees of that size. Um, but usually, people are talking about pruning slash pruning branches and stuff like that. It's in piles. Man, you got to have the equivalent of 5 big trees worth of piles per acre, and it's got to be over a wider area. So if it's just one property, 1/2 acre, probably not a big deal.
Thank you very much on that. That's
Mhm.
kind of what I was
Yeah.
thinking. Are there any mitigation strategies that we can use to help break out of the death spiral?
Well, just what I had on the previous slide here is unfortunately, the most difficult thing for us about drought is not just diagnosing it. You go out, you're an insect expert. I want to be able to tell you you have Doug fir beetle, and here's all the tools you can use for Doug fir beetle that are effective. But then we diagnose drought. It's really not satisfying. It's like I don't know what else killed your tree. I just have to leave it with drought, and then you're not satisfied either because you're like, well, what do I do? It's very challenging. It's only about prevention, and you can't change the weather. Um, we wish we could, but yeah, that's. Uh, I mean, there's probably people who know more about it than I do, like plant physiologists and stuff. And
Hmm.
but really, if you have access to some watering during the season, not overwatering, not watering all the time, because trees will get used to that. But if you have some way to get them through.
Thank you. So do you find there's a difference in tree mortality from outbreaks between tree plantations and other areas? It looked like on the slides they were mostly in tree plantations.
That's mostly because that's where I work, is
Yeah.
those type of natural stands or plantations.
Hmm.
Um, you know, they're usually in the urban suburban environment, it's you tend to have more defense of the fact that the forest in a city is so diverse. And that's one of the things that maybe I didn't put on the earlier slide, is diversity is your friend. Because, you have those predisposing factors like a drought, and then the contributing factors of the insects. Well, those insects aren't going to kill every tree. They don't like all the trees. They only like one kind, that particular insect. And so um, that is one defense that you have, is just single trees here and there. It's not going to be like in my pictures of the natural forest, like half the trees dead, thankfully.
I think that kind of goes into a question that I had personally. And also a question here is regarding drought and heat events. Do you have a sense of upcoming El Nino cycles, or whether we should avoid picking specific years to focus on planting efforts? And in addition to that is kind of your take on climate adaptation species as far as gene move of, farther south, not
Yeah.
necessarily whole different genus and species, but just, climate
Yeah.
adaptation species, which has been a big talk. So I think I'm just curious on your take on that.
Yeah, our general approach telling people about seed zone movement is there are a lot of studies out there doing like Common Garden, where they're looking at, kind of extremes where you're moving Doug fir from California up here. Um, and yeah, Doug fir in California is more drought tolerant, but then in these Common Gardens, sometimes they're finding that they're so off site, they get other problems. They get more foliar disease. They just don't like being wet all the time. And they're dying or stressed from that. But I think moving sort of one seed zone from the south is perfectly acceptable in general. And whole different species, like again, in the urban environment, you have the luxury of planting a sequoia or something that's just going to be bulletproof in those terms, until something comes along that kills sequoia. We don't know about it yet. But I forgot the first part of your question already.
I think we're wrapping up on time anyways here, so we can
I had a good answer.
I think it tied into it there. So
okay, put it in the I guess I could stick around.
there's a bunch in the Q&A if you want to get in there. But
yeah,
thanks a
I'm
lot,
gonna
Glenn.
watch the next presentation and answer questions at the same time. Thank you.
Thank you so much, Glenn. This was really informative and a wonderful presentation. So welcome back, everyone. For our next speaker, I would like to introduce Brittany Jones of Washington State University, who will be speaking about different types of pesticides, their modes of action and risks. And then she will discuss why different types of PPE are needed for safe applications. So a little bit about Brittany. Brittany, you can use this time when I'm introducing you to start sharing your screen. Brittany Jones is the Senior Extension Coordinator for the Pesticide Resources and Education Program at WSU Extension. She focuses on IPM tactics for pests in commercial and residential settings. She received her PhD in entomology and worked in both Texas and Oregon before moving to Washington. And her goals are to conduct IPM outreach, to network with many agencies and organizations as possible, and continue to learn as much as possible about the state of Washington so she can assist with any exciting and or challenging things that come our way. One other thing about Brittany, thank you. She is joining us today while feeling very sick. There's like a lot going around, as we all know. And so she's going to stay off camera because that's what feels more comfortable today. So thank you so much, Brittany. And take it away.
Thank you all for being patient. I'm so sorry. So I am sick. I'm helping my teammates with the CEU here in Vancouver at the WSU campus. So I think yesterday I may have picked up something from talking to 100 plus applicators. So please bear with me. But yeah, thank you so much for the introduction. So let's see. Can you guys see the full screen okay?
Yep, it's perfect.
Okay, good, because I have the little like because I'm only using one monitor and not two. Okay.
Right.
So first and foremost, just real quick, I know that you probably heard about the new C&T changes that are taking place for all licensed applicators. So as January 2026, licensees during your recertification period, you will need to take either a C&T course or a quiz before the end of the recertification cycle. And WSU is currently hosting these classes. Like, I think we're close to the end of our recertification period. And so today we're going to have someone present on the C&T course. It's only 1 hour long. But if you have any more information regarding the C&T course for your license, depending on your license type, please contact the WSDA licensing department for more information about that. So again, we're offering that with our recertification courses right now. And if any of you, so what we've also been telling the applicators as well, or those who are licensed, if you have like a large group and you couldn't make it to any of our recertification period or any of our recertification courses, you can go on our website at pep.wsu.edu and click on where the red arrow says we offer it trainings in English and in Spanish. So this is the website for like registering. So you can go on our website and register, or you can call our office. I'll show the contact information in the next slide. For any information on like, hey, I would like to get my guys, taking the C&T course real quick. Can you guys stop by? And we can make arrangements. We also have an online version as well. So these are just some options available that I just wanted to let you guys know. Here is the WSU prep contact information. I'm stationed out in Puyallup, so the Puyallup Research and Extension Center. And the majority of my teammates are out in Pullman, Washington, but we'll be more than happy to make arrangements regarding the C&T. But again, for more detailed information, contact the licensing department. So just a quick background about me, like it was introduced before, I just was hired on July of last year, and I moved up here from Oregon in October. So I'm kind of learning the ropes as to what's going on in Washington. I came in an awkward time with all the certification and training changes taking place. But basically, I focus on urban and structural entomology here in the Puyallup, and I'm trying to revive that right now. Just real quick, this is my last class before I left Texas and moved to Oregon, but I was doing a pre-license training. Sorry, I hope you're not seeing my Teams note. I was doing a pre-license training for the Texas crew, and this was my last class. They said that they enjoyed it, and I think they said that they all passed their exams, their pre-licensing exams for Gen Pest. So anyway, just a little quick disclaimer, products, names, and situations are examples. This is neither an endorsement nor condemnation is needed. So what I'm going to do is kind of talk briefly about the pesticide basics. This will be sort of like a recap of like, what are the laws and safety about pesticides that will lead up into why we wear PPE. So first and foremost, let's start with pesticide basics. So why do we use pesticides? I'm sure a lot of you guys are very familiar with this, particularly those that have specific license categories, especially those that are in commercial settings. We use pesticides to control weeds. We use it to control nuisance pests, to protect our agriculture, to protect public health, as well as our buildings, and for aesthetic maintenance such as turf and ornamental. But this is just a snapshot as to why we use pesticides and why it's important that we try to balance the use of pesticides as well as non-chemical tactics. And so usually what I like to tell individuals is that, when we think about the use of pesticides, our first thought is integrated pest management, which is a decision-making program to control a pest, not necessarily eradicate it, because eradicating, unless it's like obviously an invasive species, may require some exceptions, but we're here to control the pest so that way we can maintain it and reduce the risk of resistance. But like I tell the PCOs, we have a pest management plan if the treatments are necessary, where they're occurring, where they are taking place, and which treatments to use. The reason why you want to ask these questions is because when you're reading the label, it will give you a lot of this information when you're asking these questions. So it's always very important to have a plan set in place before you go out and use the pesticides. Also, when you are planning ahead, it's also good to figure out what pesticides may be needed to shop. So say, for instance, you're looking for a pesticide and you don't have it available in the storage unit. If you have your plan set, you know what's going on, you've asked questions, you look at the site, and you're like, okay, well, I need to look for a specific pesticide. That's where the plan comes in. So again, pest management plan is often associated with integrated pest management. It's a decision-making process that excuse me, combines multiple tactics. So physical, cultural, biological, chemical, and educational. That's like the general basic concepts a lot of us have learned in the past. But over the last few years, I don't want you to like really study this, but basically this was a really good publication that came out back in 2019. And I believe this individual is at OSU, Oregon State University, if I'm not mistaken. But basically just the general consensus is that IPM is more than just the cultural, biological, chemical, physical. It's actually regarding about the communication as well as planning and organization and knowledge and resources. So like when you're getting your CEUs, like with today, you have to stay on top of your knowledge of the pest or the common pest that you may be controlling in your area. And again, it's always very important to talk to each other as well as other stakeholders, the public, do outreach, all these different things. That is all part of IPM. And so with IPM, we're also trying to really focus on distinguishing between a pest versus beneficial. I'm sure you guys have had these conversations, but I know I will get emails from time to time of people asking, is this a termite? Is this an ant? And then it turns out it's like an earwig or something that's a nuisance. And so I have to give them sort of like a detailed response saying, this is not necessarily a pest, but it can be a nuisance. Here's some simple tricks to really get that fixed. Because most of the time, if the pest is not necessarily a threat to property or to trees or to land, you can easily just find some non-chemical tactics to really control that. So like, for instance, like maybe not plant some species of plants right up against the building that can, cause an ant trail right into the property. That happens a lot. I've actually had doctors ask me questions about this, which is quite interesting. But these are just like some minimal examples about why it's important to distinguish the pest versus beneficial. Also, when you're using a label, you want to reduce your risk of accidentally targeting non-target organisms as well. So I have plenty of stories about that, but obviously I won't have time for that. I have so many different stories with beneficial. My favorite one was I had a farmer that thought that he had a yellow jacket issue. This was down in Texas. And he came in my office with a jar of bees, like live bees. And he was like, these are yellow jackets. They're killing, they're stinging. I'm like, are you sure? Because these look like bees. So what I did was I put them in the fridge to let the bees kind of like calm down and cool off. And then I put them under a microscope and I was like, I'm pretty sure that these are sweat bees. And so sweat bees are solitary bees and they are no threat to individuals. But he was saying that they're building mounds near his chicken coop. And I said, yes, because the sweat bees are attracted to the dander or the feathers associated with the chickens, but they're not a threat. I promise you they don't sting unless you literally get down in there and like try to punch the mound or something, they will not sting. So I redirected him to someone that's a bee specialist or a pollinator specialist to give him more information on that. So that's just sort of like an example of why it's important to distinguish between a pest versus beneficial. You will also come across individuals that insist that it's a pest. All you have to do is just stay calm and state the facts. That is something I'm sure a lot of you guys do on a regular basis, and that's what the PCOs do. I've been doing a lot of ride-alongs with the PCOs, and 90% of their job is professionalism and talking to the customer, and that is a nightmare. Like customer service, once I got out of retail, I was like, never again, but it's coming back. So what is a pesticide? Obviously, ICIDE, the suffix means to kill, but pesticides also means to prevent, control, repel, and or to mitigate pests. Pesticides is also an umbrella term For other specific types of pests, such as fungicides, you're killing fungi, rodenticides, killing rodents, insecticides, killing insects, herbicides, and so forth. But pesticides also include plant growth regulators, defoliants, and desiccants. So with pesticides, they have adjuvants, and these are substances added to formulations or a tank mix to increase effectiveness or safety. As you can see in this photo right here, just with water alone, how it just sticks to the surface of the leaf, but not necessarily penetrate it to like protect the leaf or control a pest. But adding sort of like an adjuvant in here, it shows that it's just spreading across the leaf, really penetrating it, and depending on the pesticide, it either protects it from insect, plant pests or potentially plant diseases. That is a tongue twister. And also with pesticides, you have different formulations. A lot of you guys are familiar with that with the label, particularly with the trade names, EC, emulsifiable concentrates, wettable powders, granules, baits, dust, aerosols. That's why this goes back to the pest management plan. Once you get all that information as to what's going on, where the site of the pest activity is going, this is where it's important to really pay attention to the formulation, because there may be some restrictions associated with applying pesticides at the site. And it's also very important to read the pesticide label to make sure that the site of application is on that label. So like, is it labeled for turf grass? Is it labeled for ornamental settings? All those different circumstances. It's always important to do that. Also, some of these formulations may leave residue. Oftentimes in structural settings, for instance, a lot of pesticide products that are very effective will leave residue on carpet or curtains, and that can potentially lead to issues or concerns from customers. So they now have to find alternative ways. There was a joke that I used to say with a lot of the applicators that I learned from my boss down in Texas. He said, you guys are pretty much doctors. You have to learn chemistry, you have to learn entomology, you have to learn biology. You also have to be a meteorologist, because one of the things I'm learning here is that it rains a lot here. So that has to be fun with applying pesticides. And so you have to compile all these different things when you're having your pest management plan and or applying pesticides, depending upon how the plan has been written out. And so with pesticide ingredients, you have active ingredients and inactive ingredients. So active ingredients, that's the pesticidal activity. We often sometimes communicate about pesticides with the active ingredients. So like, okay, well, these are neonics, and now neonics are restricted to, commercial applicators only versus like homeowners in the past, or all these different types of active ingredients. The reason why is because the trade names are constantly changing. So we want to be careful with constantly using trade names. So we prefer to say active ingredients to really focus on how effective it is. And then of course there's the inactive or inert ingredients that sort of improve the efficacy, or may just be simply as trade secrets on how exactly that pesticide is formulated to target a pest. So how do pesticides work? There's contact, systemic, and selective. Contact, where there's direct, where a pesticide must touch the pest at a susceptible part to injure it. Systemic, disperses through the internal system of the pest. And of course, there's also selective, where they only affect a narrow range of pests, such as broadleaf herbicides, for instance. And so with pesticide classification, we have EPA restricted use classification as well as general use. But obviously, we want to also look at the state of Washington. Is it restricted, or is it also general use? It's always good to really pay attention to that when reviewing the pesticide label and making sure that it's appropriately registered. And then this is where the PPE comes in handy. So with the signal words, you see caution, warning, danger, danger, poison. So basically, as I'm going down the list, the more I guess maybe high risk. We try to not say this is dangerous. Like, we try not to say that, particularly to the general public, because you say dangerous and everybody's Chicken Little, the sky is falling. So we try to say something like high risk or low risk. So for instance, a pesticide with the signal word caution, it's a low risk versus a pesticide that has danger poison, that's a high risk. And that also should tell you, okay, I'm going to need a specific type of PPE. Obviously, with the minimum requirements, you want closed-toed shoes, long sleeves, long pants, obviously chemical resistant gloves, that's also very important, but the label will also tell you what other types of PPE that you will need or may need depending upon the pesticide and how it works, particularly when it affects our health. So for instance, here's an example of one right here where it says caution, and then here's one right here that says warning, and then danger, and then danger poison. And so it's also very important that we look to see if it's an RUP or restricted use pesticide. Also, when reading the label, always pay attention to the first aid. Be sure that you're aware of what may need to take place when it comes to this. I've been meeting with a lot of applicators and talking with them, and oftentimes what happens is that there's only one person out on the site and they may get injured and they may not have anyone available to help them out. So a lot of the guys, they said, if possible, they try to have like maybe a partner with them to go out and do the application when necessary. So that way, if anything happens, like they accidentally swallow, they accidentally get in their eyes and they can't get to their cell phone and call because, they're incapacitated. It's always good to really pay attention to that first aid, which is why PPE is very, very important, because we want to avoid this. And I will share stories about that in a minute. And so obviously with the precautionary statements on the pesticide label, the PPE, here's a requirement right here. Applicators and other handlers must wear long sleeve shirt and long pants, chemical resistant gloves. That's one that's very, very important that you should wear, particularly if it states that on the label, as well as shoes plus socks. I can't tell you how many times I have driven around just out of curiosity, and I have seen individuals with short sleeve shirts walking around spraying pesticides, or looking like they're about to go to the beach and they're spraying pesticides. You don't want to do that. Always remember that you want to protect yourself, not just the environment, but also yourself. Even if you've done it for over 20 years, it's very important that you wear your PPE, because again, pesticides can be hazardous to our health. Even if we think that, okay, we got a little splash, it's low risk, it's fine. But when it constantly happens, particularly if it's your full-time job, it will eventually accumulate in your system and cause all sorts of health risks, which I will get to now. Okay. So how pesticides affect our health. So again, a lot of us are familiar with this formula. This is from like the core manual from Laws and Safety. Hazard equals toxicity and exposure. PPE reduces our exposure to these hazards, which are pesticides. So again, back to the signal words, caution, danger, warning, all those different things. That tells you how risky it was, like I was saying earlier. And PPE reduces your exposure. So that's why it's always important to wear your PPE. And then of course the toxicity, I will get to that in a moment when it comes to acute or chronic toxicity. So again, harmful effect of pesticides, acute short-term injury, like you get it immediately in your eyes or you accidentally swallow it. And depending upon the pesticide, they may say, okay, do not induce vomiting if swallowed or something like that, which is why it's important to read the label beforehand. And then acute toxicity symptoms are completely sudden or dramatic. Like you may get like that skin sensation, particularly with pyrethroids. That's a common side effect of direct contact of pyrethroids. And then of course there's chronic toxicity. Again, this is one that's sort of like the silent killer, where it's repeated non-lethal exposures. So like, I think one of the common examples are the use of organophosphates. I think a lot of us are pretty much kind of away from organophosphates, but there are still a few people that use it because they believe and they know that it may be effective depending upon if it's registered or not in their state. And when you use organophosphates over time, you have to constantly go to the doctor to check your, I think it's like cholinesterase test, because it can affect how much cholinesterase is produced in your liver, if I'm not mistaken. So that's why it's always very important to pay attention to the harmful effect of pesticides, read that first aid and the precautionary statements, and wear your PPE. So a lot of you should be familiar with this. It's always like the human body. So basically the takeaway is the thinner your skin, the higher the absorption rate. So think about, for instance, you forget to wear your gloves. You're applying pesticides, and then you go and touch your cell phone and you don't wash your hands because there's no sink in sight or there's no water hose in sight. That is considered sort of like how you can potentially become exposed to the pesticides, especially if you do not have your appropriate PPE. And so with systemic effects, when the pesticide is absorbed and distributed throughout the body, it can lead to breathing issues, vomiting, cramps, chills, and nausea, and in extreme cases, death. And sometimes these effects may be confused with other illnesses, such as an asthma attack, an allergic reaction, things of that nature. So that's why it's always important that you are proactive about your health and you let your PCP or your medical provider know that this is your job and there are risks associated with it. So that way the medical professional can know exactly what to do and exactly what to test. Because you'd be surprised how many medical professionals are not aware that pesticide application is a thing. It's shocking how many of them are not conscious of that, but it's getting better. Ways of exposure, so where pesticide made contact, so depending upon the formulation, it may influence the rate of absorption. So like I was showing earlier with emulsifiable concentrants or aerosols are really deadly, as well as dust, because the finer the particles, the easier it is for you to breathe it in, especially if you're not wearing the respirator. That is very, very risky. And then again, the thinness of the skin, particularly the older you get. So the older you get, the thinner your skin, because you're losing that elasticity as well as the biotin production that your body naturally produces. So that's also going to increase your risk of exposure. Presence of cuts and abrasions on the skin, application techniques. I've seen the guys use the dust, particularly when they dust around the buildings and it's windy outside, which is very common in the PNW. The dust and mist, they go flying right in their faces, and sometimes they're not wearing masks, and I don't say anything because I said I'm just here to observe. I'm not here to spy and snitch. I'm not a snitch. So and then another way of exposure is not washing hands after application, which can be very difficult, particularly when you're out in the middle of nowhere applying a pesticide, and then you may not have direct access, but hopefully you may have some type of cleaning equipment or decontamination equipment in your trucks to where you can immediately wash it off. Ways of exposure, laundering work clothes. I'm sure a lot of you guys are aware of it. It's always very important to launder your work clothes separately from your everyday clothes, particularly if you have family members living with you. Always try to keep that separated. And I also try to suggest having the washer machine in hot water with like a full load but no clothes, and just kind of do like a mix right after you wash your pesticide contaminated clothes. That's a way to kind of like reduce the risk of cross contamination to everyday clothes. Obviously fine particulates, and with mixing and loading, that's the most hazardous way of exposure is mixing and loading, because you're handling pure concentration chemicals. And then of course, cleaning up spills. And I like to make this as a joke. This is very important. I've seen a lot of the seasoned veteran applicators do this, sniffing inside the containers to determine the pesticide product. I've had some guys sniff it and they say, oh, it's dicamba. So please try not to do this, because that is the inhalation route that we're trying to avoid. So please do not do this. And so finally, we are now focused on PPE. How much time do I have left with this presentation? Hopefully I'm not going too fast.
You have until 10:06.
Okay,
Yeah.
great. So
Okay.
let me slow down a little bit. Hopefully I think I have a slide. Thank you so much. I should have some like slides in here where I can share quick stories. Okay. So again, now that we have all that information, we learned about the signal words, we learned about the different formulations, we learned about the risks associated with our health, such as acute chronic toxicity versus systemic versus local effects, and why it's important to familiarize ourselves with that. This is where PPE comes in. So what is PPE? Obviously, it's personal protective equipment. I've heard some guys say PE, which I thought was interesting, but I guess because it's easier, I don't know. But PPE is personal protective equipment. And so that information is all right there on the pesticide label. So I think this is a snapshot of I think it's like Termidor that the guys often use and for termite control. But for example, with this red arrow pointed, applicators and other handlers must wear long sleeve shirts, long pants, shoes plus socks, chemical resistant gloves. That is very, very important, such as barrier laminate, butyl rubber. There's all different types available, but they just want to let you know that it has to be chemical resistant, particularly if you want to be in compliance with what the label states. So why do we need PPE? Again, we are protecting ourselves from exposure to pesticides. Again, no matter how many times you've done it, it's always important to wear your PPE. You can be the most seasoned applicator on the planet. You can do everything so well, but it's always important to keep that protection on you, as well as protect your family as well. I know an applicator down back in Texas who he inherited his father's company because he ended up getting sick, and they believe it was associated with his long-term use of pesticides. And the young man said, sometimes I see him without PPE, and he said, this is just how we do it. And he always questioned that. And now he's in charge of his father's company. So we always want to think about that too. Like, how will that affect our family as well in terms of exposure to pesticides? Not only that, but also when we come back home and we're wearing potentially pesticide contaminated clothing and we leave it on the floor or something. And then if you have a pet or a child crawling on top of that, that can also be an issue. As well as PPE is also effective when used properly. That's also very important. That's why it's important to check your PPE for wear, tear, or any other damages. Very common example, a lot of the guys, they'll fill up their gloves with water and then squeeze it to see if any holes or if any water will leak. So what are the different types of PPE? Well, first and foremost, here's disposable PPE. Oftentimes, a lot of the guys prefer to use this when they're conducting a simple inspection. And I think that's very important. There's also been talk recently about individuals. I don't know if you guys may not be involved with this, but crawl space inspections, there have been individuals getting injured or possibly facing death from crawl space inspections because either there may be a gas leak in the crawl space and they don't, the homeowner may not be aware, or there may be, like rodent activity. And a lot of us are aware of deer mice and hantavirus. And there could be loose nails like on the floor of the crawl space, or just when you're out in the field, like outdoors. It's always good to wear that disposable PPE to protect yourself. But they're not always chemical resistant. So always keep that in mind when wearing PPE or reviewing that information. Some common disposable PPE are latex, vinyl, and nitrile gloves, and disposable shoe covers like right here in the photo on the top right. And then, of course, there is waterproof PPE. So that's like plastic or rubber, keeps water-soluble materials out, but they may not be effective against oil solvent-based products. So there's waterproof and there's water resistant. So waterproof is much more effective against like water-soluble materials, but there's also water resistant that may not be as effective as waterproof. So it's always important to make sure you read the packaging, and if it states specifically if it's excuse me, waterproof or water resistant. So with water resistant, if you become saturated with the product, and particularly if it's a water soluble material, it can easily be absorbed through the fabric and come to contact with the skin. And then, of course, there's also non-chemical resistant PPE. This does not qualify as proper PPE, even when handling dry formulations, because remember, the dry formulations could potentially be the pure concentrated pesticide that actually can cause high risk of health or adverse health effects. So common ones are cotton and leather, particularly the leather belts around pants. A lot of people don't really think about that, but that's actually highly absorbent. There are some exceptions to some pesticide labels where you can have cotton-like gloves, but I think it's very, very rare to come across that. That's on the label. And then, of course, there's also chemical resistant PPE. It's very, very important that you review the PPE packaging, and it states that it's chemical resistant. So during handling with chemical resistant PPE, the pesticide is not readily absorbed. There still can be some exposure, but it's so minimal because they're not chemical proof. And we'll get to that in a minute with the different letters and numbers. So the lining may also be made of non-absorbent material, and some common ones like that pesticide label was showing are PVC plastics, rubber, such as butyl, nitrile, and neoprene type gloves. And oh, I thought I had a slide here. Yeah, here it is. I'll get to that in a minute. That's a meme slide. So with hand protection, there's also the gloves unlined in elbow length. There's many different types of chemical resistant gloves again, and then try to avoid cotton or fabric gloves unless that pesticide label requirements. And again, I think there are a few exceptions with some pesticides that may suggest using it. And I think it has to do with like fumigation, but that's a completely different topic. But obviously we, with cotton or fabric gloves, discard immediately after use. So real quick, just a real story. The reason why I have this up here was because I had a moment. So when I finished my master's program, this was right after, like right at the tail end of the 2008 recession. Right after I finished my master's program, I was still living in Tennessee, where I'm originally from. And the job that I got was at a chemical company where I was working with the research and development team on formulating new products, such as like cleaning products, paint strip products, dehumidifiers, all those different things. And so the warehouse on the ground floor, there's just a bunch of drums of just pure chemical concentrate. And so what happened was, when I first started working there, my boss said, hey, look for some steel toe work boots because that's required. And I go, okay. So I was very nervous because I was new, and I did not like the boots because they hurt my feet. And I was taking too long to find boots when I was going out shopping. So I just picked the cheapest shoes I could find because I was trying to be nice. And he's like, okay, great. And so what I did was, when I left the research and development lab, which was upstairs, I took them off and put on my regular tennis shoes because my feet were hurting. I went downstairs, and what happened was somebody put a stack of boxes for some reason next to one of the drums, and I needed to get access to those drums to collect samples of the concentrate. So what I did was I moved the boxes, but they were heavy. I mean, super heavy. So I ended up knocking one of the boxes over, and then one of the boxes toppled towards me. I immediately take a step back. I bumped against the drum, and some of the concentrate spilled over, but thankfully I moved back far enough to where it did not get my shoes, and it was like on the floor. And so I let my boss know, and he said, why are you not wearing your shoes? And I said, well, I was nervous, blah, blah, blah. I give him the song and dance. And he said, Brittany, it's okay. Please put on your steel toe work boots. So moral of the story, please be careful. I know PPE may be uncomfortable in some settings, but you'd be surprised how crazy life can get. And that was one of my like really crazy stories. So this was the moral of my story, was try not to be stupid. Just follow the rules and you will protect yourself. So moving forward with chemical resistant gloves, the pesticide label may list the different categories. So like A through H, I haven't come across many lately. I think a lot of them just tend to just spell it out, but the categories are based on the solvents used in the pesticides, not necessarily the active ingredients. It's a little tricky to kind of talk about. That's like a whole nother topic. But you can probably find like the PPE, like the chemical resistant categories somewhere online. I took this straight from Oregon OSHA. They had a pamphlet that was free and available, but they just kind of list the different categories available and what type of protective material can be associated with those categories. Just the general consensus of it. And depending on the type of glove, there's also a resistant time limit. So glove thickness is very, very important. So the thicker material, the more protection they provide it. So oftentimes we say chemical resistant gloves with a thickness level of 14 millimeters or above. And so there are certain types of gloves like barrier laminate and polyethylene that does not necessarily specify material thickness. And so another thing about this is that they'll give you the letters and sort of like the codes, but there's also sort of like a time limit key. So like, for instance, if it's like high, like if it's listed as high, that means it's highly chemical resistant. Clean or replace PPE at the end of each day's work period versus like slight, where it's a slight chemical resistant. Clean or replace PPE within 10 minutes of contact, things of that nature. So it just very much depends on the type of material that you're using. So again, now not only do you have to be a meteorologist, a biologist, entomologist, now you have to suddenly be sort of like, I guess maybe just engineer of some type. I don't really know what this is called, maybe an occupational therapist to figure out what type of products you need to protect yourself. So moving on from gloves, we also have eye protection. A lot of you guys should be familiar with these. We have the safety goggles, face shields, and safety glasses. So safety goggles, they're snug fitting. Face shields can protect from mist in windy settings, particularly splashing during mixing and loading, and as well as safety glasses. These are more just sort of like minimal tasks. So safety glasses I like to associate with disposable PPE. Like again, like you're doing a quick inspection or a survey of a site and you want to protect yourself because you have no idea what's out there. You'd be very surprised what you just randomly find just out in the wild. And obviously with face shields and goggles, particularly if you're using fine particulate matter or fine particulate products, these are very important to have. Eye protection. Prescription glasses are not protective eyewear. Always keep that in mind. Consider prescription safety glasses or safety goggles that can go over the prescriptive glasses. Very important you keep that in mind. And if eyewear isn't specified on the label, it is suggested that you use the safety glasses. You can just do a simple Google search, go on Amazon or wherever you go to get your products and make sure you have some available. And if you're wearing a full face respirator, eyewear, obviously you don't need to have like both like the safety glasses and the respirator. The respirator, full face respirator should be enough. And with the respirators, obviously, you want to make sure that they are approved. Like, don't just go to some random, like, I don't know, Temu or Alibaba and get some respirators. It's always important. You make sure you have the right type of respirator available. Check them before and after each use, and please get your fit test. This is very important. I also was told by someone from OSHA that they highly suggest that if you have significant weight changes, like you lose a lot of weight and your face shape changes, it's good to get another fit test. It's very, very important you do this because you will be wearing that respirator, particularly in the hot weather. And you want to be able to breathe properly, because if you're not breathing properly, the first thing you're going to do is grab it and take it off. Now, if you don't have those gloves or your hands washed, that is direct contact. So these are some things to keep in mind. So with the respirators, you have different codes, NRP, and the minimum efficiency, 95, 99, 100. So a lot of us remember from COVID, they were like, please wear your N95s. Basically, it's just the most basic respirator that has 95% efficiency. And then there's also body covering. So we have the gloves, we have the glasses, now we have the body covering. Oftentimes, a lot of individuals wear this body covering for the extremely toxic pesticides, the ones with danger or warning signal words. They also like to wear this when they're mixing and loading pesticides, like in this photo in the bottom, excuse me, in the bottom right corner. Some body coverings may be disposable or reusable. I think it's called the Tyvek covering. I know an applicator I was shadowing, he wore the Tyvek, the full covering when he was doing inspections somewhere because he knew that there was rodent activity and he wanted to protect himself. So he put that on, and he also had knee pads on because he knew he was going to get on the ground and, you know, hard surfaces and everything. So these are just little things that can also help reduce your risk. But when it comes with mixing and loading, you definitely want to wear a chemical resistant apron, like obviously not a cotton apron, you know, that you use in the kitchen all the time that just absorbs everything. That's useless. Please try to have a chemical resistant apron. And then, of course, there's also foot protection. So not the viral Balenciaga boots that are in the top right corner that I have an X on, but the actual foot protection. So when handling moderate or highly toxic pesticides, wear unlined chemical resistant boots that cover your ankles. So there are some types right here, such as rubber and butyl, again, like in this photo down, these green boots down here. Canvas and leather shoes can be worn unless the label specifies otherwise. I'm sure a lot of you guys have heard this a lot. This was beat into my head when I first started in extension during COVID, but the label is the law. The label tells you everything. And if you have questions, contact the manufacturer, or sometimes you may even want to contact compliance. Compliance loves questions. They're like, you're like, hey, this label says this. Am I reading this right? Or ask someone that has done this longer than you, someone that's used the product before. These are just some things to keep in mind when protecting yourself. So real quick, I have about 5 minutes left, but real quick, just a story. I actually did this backwards. I meant to put this story with the glove section, but basically what happened was I used to work in a forensics lab and we would handle dead carcasses, basically dead pigs that were donated from the animal department, animal health department. I can't remember what it's called. And so when we were doing fly studies or degree day studies for the flies, we would put out the carcasses in the field and then come back and see if there's blowfly activity. And so I was handling the carcass without gloves because I was stupid. And I ended up sneezing. And the first thing I did was I touched my nose. So you can imagine what happened. Yes, it did get infected. Yes, I did go to the doctor. But, you know, on campus, there's only like one parking space, you know, for anything except unless you pay. So I ended up parking illegally so I can get immediate medical assistance. It was infected. I had to get a nose spray. I ended up getting a parking ticket. So moral of the story, please wear your gloves. Please wear your PPE. Don't be like me. So yeah, I still make me stupid. So finally, how can we reduce exposure? Obviously, evaluate the risk. Like I've said before, your pest management plan, when you ask questions, when you survey the site, when you read the label, you do a lot of critical thinking when it comes to this. Like this is where it becomes quite challenging. And so evaluate the risk. Read the pesticide label first. Look at the signal word precautionary statement. Does this product fit into your pest management plan? If not, try to choose an alternative. Think about exposure risk for common routes of entry, such as the inhalation, accidental ingestion, as well as your skin. Always remember the skin is our first line of defense. It is our largest organ in our body, so we want to protect it as often as possible. Please follow all directions and precautionary statements on the label. And again, consult with experts if you do not understand something. Incorporate good behavioral practices, such as hand washing immediately after application. Try to do it as long as possible, such as singing the happy birthday song. And of course, wash before eating, drinking, smoking, or checking your cell phone as well. Always do that. Check your PPE before and after each application job. And not just check your PPE, check your equipment. Oftentimes, a lot of guys, I understand the end of the day, it's like 6, 7 o'clock. It's hot, you're tired, you want to go home. but it's very important that you still want to at least check your equipment, at least like the basics until the next day. Then check it first thing in the morning before you go on your route, or if you have somewhere to inspect, because if the equipment malfunctions, you're going to have high risk exposure. Obviously, wear the minimum clothing requirements that the label states all the time. And again, check and calibrate the equipment. Launder your work clothing, put it in hot water. It's much more effective. There are studies done. Cold water is not effective. It is hot water. And also, I know some sites, some areas may have a washing machine like on site. I don't know if everyone has that, but I know some people do. But definitely wash it in the hottest setting you can. Separate from family laundry and dry it in the hottest setting or hang dry in direct sunlight. And again, it recommend that you run an empty load in hot water after washing the pesticide soaked clothes. That's very important. Um, Again, when you're handling contaminated clothing, wear rubber gloves, wash daily or as soon as possible, and wash your PPE after pesticide application, and store the PPE in designated area away from pesticides. So I have about 1 minute left. I'm so sorry that I kind of took a lot of time, but I would like to thank my teammates, my supervisor, Wendy Sue Wheeler, for letting me borrow a couple of slides with permission, as well as Doan Jockson, who's currently teaching the pre-licensing training downstairs. I appreciate her allowing me to use some of these slides. So this is my email. I am stationed out in Puyallup. Again, I do a lot of urban and structural trainings. I'm trying to revive it right now, but please don't hesitate to email me. I actually just got my direct office line and I forgot to put it up here. It took them almost a year to finally get that. Uh, but yeah, so if you have any questions, if you ever want to like collaborate on something, or if you want to show me something cool, I would be more than happy to join. I love going out because I'm only going by the books, and I learn much more when I'm outside in the field to see what you guys really do. And I can tell you right now, the books do not cover what you guys do outside. The books have this idealized view of what pesticide application is, but really it's just you wake up, you don't know if something's on fire. So yeah, so I would appreciate it. So yeah, thank you so much. I'm so sorry that we don't have time for questions, but thank you.
We
I
do.
appreciate it. Oh, okay, yeah.
Yeah, Brittany,
Hopefully
you
I can
nailed
answer.
it. You totally 100% nailed it.
Okay,
Even with the
great.
delay in the start, even with being sick, we thank you so much. That was so informative. And that I think was the exact presentation that we have been getting requested to
Oh,
present at this webinar, at this series for a long time. So that was wonderful.
oh,
Yeah, no, thank you, Brittany. That was an A+ presentation. And if that's what you're like when you're sick, I don't even know what, it's like when you're feeling good. I wanted to, for me, something that I'm curious about is I wonder if you would talk a little bit more about the C&T course and maybe explain why it was developed and what kind of the focus is.
yeah. So this is my understanding because, like I said, I came in when this was already done. So my understanding is that what happened was that a couple of years ago, EPA did a lot of certification and training changes, and they gave it to the states to revise their changes, and then the states write a report, send it to EPA, and the EPA reviews it. So I think Washington's approach was to also say, hey, we made some significant changes. We need the guys that are currently licensed to be aware of this so they can either take a quiz that demonstrates that they understand the changes that take place, or they can take a class that's either hosted by WSU or someone else, that pretty much covers what some of the changes are with the certification and training standards or the competency standards. And you have to do it within your recertification period. And so, like right now, we have a bunch of guys that were not here yesterday, but they're here today simply for that course because we're in their area and they're saving so much time and money. So, that is my understanding with the certification and training. Like it's only 1 hour. That's the presentation, but the quiz, I don't know much about. I think you will have to contact WSDA for more information about that.
Okay, excellent. You've had so many good stories. I'm wondering what the worst version of PPE you've ever come across. Like if you've come onto a work site and you see something and you're like, holy cow, what are you guys thinking?
All I can say is the worst version is just no PPE. That's the worst version. Like, I've seen an applicator dust a window and he had no PPE, and that dust was flying in his face, on his body, on his clothes, and his supervisor gave him an earful. It was interesting. Um, but
Wow.
that's pretty much the worst. In terms of creative PPE, I don't know from the top of my head. I think because they knew I was coming, they were trying to be nice. And I told them, I said, I'm not with investigation. I'm not a snitch. I just want to know what you guys do. But really, the scariest one was just them not having it on. They're like, guys, I'm in a rush. Like, I'm trying to get through my route. I don't have time to put on my PPE. And then the supervisor's like, yeah, but you're still being exposed. And then he gives the lecture on chronic versus acute toxicity and all those different things. And sometimes they remember it, but not always. So
Wow. We're short on questions at the moment.
oh,
I
um,
know.
let me think.
Shocking.
Let me think here. If I can ask a question, so what is everybody's like background, like in terms of the audience? Are these like turf and ornamental? Are these like ag, farmers, forestry? I'm really curious.
I think it's a mix. I mean, a lot of the people on this at this seminar are people who work for the city of Seattle and are sort of like public horticulturists.
Oh,
But
cool.
I imagine, and I'll leave it to Kate or Bridget to add if there's also. I mean, I think agriculture is a lesser impact at the west side of the state.
Yeah,
But,
yeah.
and then I think we also have like landscape companies and some professional applicators. So it's sort of a mix.
Okay, cool.
Yeah.
Yeah, Bridget gave us a breakdown of the last one. I forget what it was, but it's like mostly public sector gardeners, like landscape industry, really, like by and large, is what this
Okay.
webinar series is like. That's our primary audience. Particularly those who work for City of Seattle, but we welcome everybody, right? But that's like our
Okay.
primary audience is City of Seattle staff, people who work at managing landscapes. But there are some other folks too, but it's really nice because this is a webinar that focuses on that audience rather than agriculture, and the primary information is going to be slightly different. But I did see we have like a little side Teams chat too.
Okay.
And I can see on there was a couple questions. Eric was asking if you have any tips for field staff on mixing and washing.
Um, Usually what I try to do or what I try to suggest is do it. You get to the site. I'm not, so this is why I like to do ride along so I can see what's going on, because this may be different from when I deal with the commercial applicators. But most of the time, so like for instance, the commercial applicators will do it like right there at their company building, because they have a site dedicated. There's like a little concrete slab with a water hose attached to the building where they do the mixing and loading right there. But when it comes to on site, I guess simply just try to be as careful as possible. Maybe I've seen some do it inside of the truck, but it depends on how large the pesticide product is. So I know that try not to, obviously don't try to do it like right on the grass, because that's environmental contamination. Try to find like maybe like some pavement that's pretty far away from like water or bodies of water. Try to do that. That could be another thing to do. But that's what comes to mind from the top of my head. And again, this is why I ask for ride along, so I know exactly what people are doing, so I don't give the wrong information. I hope that answered your question a little bit. Sorry.
Yeah, no. Do we have time for one more, Kate?
I think just one more.
Just one more. Do you have any, Brittany, do you have any tips for applying when the weather is wet? Which is a big,
Applying when wet, it depends. I think you should probably try to choose a pesticide product that is not so like there's like a huge precautionary statement about like groundwater contamination or runoff. something that's a lot more effective and a little bit more resistant to like, mist or rain. But that's all I can think of from the top of my head. That's something that I'm actually learning right now because, yeah, I've only been a PNW for 3 or 4 years and I still don't know what takes place.
That's fair.
That's a
That's
good
fair.
question though. That's actually been asked. I was at a I think it was BASF. They were having a conference and the guys in that operate on the West Coast were like, "What do we do when it's raining all the time? Because you guys down east or south don't have this all the time." And that was they were still debating on what to do with that. So I will ask around, and that's a good question. Could you send me an email and ask that question again, and I can see if I can ask around for an answer? Thank you for that
Absolutely.
question.
You bet. You bet. All righty.
Hey, Brittany, that was so wonderful. And I just echo Steve, if that's what you're like when you're sick, my, oh my.
Sorry, thank you. I really appreciate that. Thank you, because my throat, it's burning, guys. Like,
Oh, please have some tea. Take care of yourself.
yeah,
I'm so glad that you are now with us here in Washington State and that you are a resource and you're here, you're nearby in Puyallup. I was just there on Tuesday. I wish I had seen you and been able to meet you in person. Had I known.
Oh,
Um,
I was out driving down here to Vancouver, so we probably would have missed each other.
so we would have missed each other anyway. All right. Thank you again, everybody. We are going to take a quick break now. Hey, welcome back, everyone, for our final presentation of the morning. Excuse me. I am super excited to introduce Will Peterman, Ben Lee, and Tony Dickey of the Washington Native Bee Society. So the following presentation will take us on a virtual tour of native bee habitats in Seattle's Jefferson Park area, including the Beacon Food Forest and the Bill Wright Golf Complex. I'm going to give a brief bio and intro to each of you during that time. I forget who's sharing slides first, but you can go ahead and start sharing your screen to get that queued up. So first, I have information about Will Peterman. So Will is a lifelong geek who stumbled into pollination ecology in graduate school and remained fascinated by native bees, even as he was drawn into the attractive nuisance that is the Seattle software industry. He's an early adopter of digital insect photography and used that as a leverage to gain entry into the UW biology community, where he spent a decade learning bee taxonomy and population monitoring techniques from Dr. Evan Sugden. Not sure I'm pronouncing that one correctly. And he would like to remind everyone that bees need dirt, as here. Next on the panel, we have Ben Lee. Growing up in Hong Kong, surrounded by nature, Ben developed an interest in insects from a young age. He moved to Seattle for school in 2014, attending Shoreline Community College, and eventually graduated from University of Washington. And over the years, he cultivated a specific interest in hymenopterans, and after reaching out to Lincoln Best, joined the Master Melitologist program in 2021. Finally, Tony Dickey on our panel lives in Seattle, where he moved to from Philadelphia in 1992. He spends most of his time in West Seattle, where he learned to deeply appreciate bees and other pollinators. A short attempt at beekeeping made him realize the importance of the connection between pollinators and what we grow. He is a core volunteer at Beacon Food Forest in Seattle. He oversees the Pollinator Plus effort there. He loves chasing bees around to photograph, which helps him appreciate all pollinators and other invertebrate species. And he urges people to think of food as shelter, as something all of us need, even the smallest species on our planet. Oh, I love that. Okay, I'll take it away, guys.
All right. Well, like she said, my name is Tony Dickey, and as your screen says, bees need dirt. And this is where our tour actually started. This is where the whole story started. It is a piece of land between the Beacon Food Forest and the upper area of the Jefferson Community Center. And as you can see, you're looking at dirt that has been shall we say, condition. It's been lived in. There's holes there. If you look a little closer, there's shading in different levels or different areas of that dirt. So this is one of the clues that you can look for if you're interested in finding out about insects that nest in the ground. So we are Washington Native Bee Society, and you can find us at wnativebeesociety.org. And it started in West Seattle when I had much darker and longer hair. I helped build that farm. It was a permaculture farm, and we did have honeybees for a little bit, and we realized after about a year that it's really a lot of work. But that really introduced me to the world of native bees. This is a picture I took in 2017 with the tablet, and those are leafcutter bees on a sunflower. And so what we're going to explore in this webinar today is, where do bees live? What bees live in soil? Wildlife diversity in cities, and landscape considerations for insect diversity. So the thing that we're finding out is, as you probably know, the urban areas are expanding around the world, expected 85% by 2100. And even though urbanization is widely regarded as a major threat to global diversity, high levels of diversity may also thrive inside cities. And so there's a lot of research being done with that. And so I am finding this, by example, the image down on the bottom right is that's Beacon Food Forest. And so you can see it's a city park, it's a city location, it's a farm in the city. And a few blocks away is a location on somebody's sidewalk. And this is something that anybody can do. They can take out the grass and they can put in a habitat that helps native bees. And so this is actually another picture of that. So ground nest, anatomy, nutrition, and location. So all of those things are connected. The ground nests are basically where bees and other insects live. And a lot of times the bees that you see on flowers, you see a couple bees on the daisies there, they live really close to those flowers. Some bees are really small, so any bit of wind is going to affect them. So they tend to be very near the flowers that nurture them. So bees go for pollen. Well, female bees go for pollen, but all insects go for flowers, for nectar. And as you can see, that yellow-faced bumblebee is very yellow-faced, covered with a lot of pollen, and that was at Beacon Food Forest last year. The other picture you see is a mining bee, and Andrinus pernurum. That is California lilac, and that is also a mining bee. That's a female, and these are different other insects that you can find in the diversity of Seattle parks. On the left, that is a beautiful ciphrid fly. That is a butterfly on lavender. And we have a couple examples of wasps. And all of those were taken either at Beacon Food Forest or right next door. And like I said, there's just years of wonder. These are all, my evolution from those tablet photographs. These are all taken at Beacon Food Forest. Upper left, that is another Andrinus pernurum mining bee on 9-bark. That is a digger bee on California lilac up top. Going down on the bottom left, that is a osmia on sweet pea. Sweet pea is great because it grows on its own and bees love it. And that is a leafcutter bee flying over Calendia. You can see the shadow in there. I love that part. And then this is a little paradise. This is somebody's backyard. And for a lot of people, they would say, "Oh, that's not a nice lawn." But for us bee nerds, that's a great lawn. It's got lots of dirt. There's ground cover there. I can tell you that there's a lot of flowers next door. So it's a little place that I get to hang out and take pictures of bees. And that's what I'm learning in Seattle. Seattle is doing a really good job of creating pollinator habitat. And so I'm going to leave you with Before we transfer over to Will Peterman, this is about 25 seconds of a ground nesting bee. This is a female. She's emerging from her nest, and then there is speculation as to what she's doing as you can see, she doesn't just leave the nest. She kind of surveys, and there's another insect that flies in there. And so there's scientific research that is being done on what is being, or what happens when they leave the nest, because there's some sort of, it's not certain as to what she's doing when she leaves the nest like that. So giving you that information, that introductory information, I will pass it over to Will Peterman.
Thanks, Tony. My name is Will Peterman. I've been working with native bees for the better part of 30 years. And I'm going to take just a few minutes to say a little about why all this matters. That is, why bees matter, why parks matter, and why we've been reaching out to you. So, okay, the big picture, the reason that bees matter is that sex works and plants can't move. So one of the great winning strategies in the history of life is to move genetic material from one thing to another thing and combine them to make a new thing. But plants run into trouble when the other thing is way over yonder and, well, you've put down roots. So instead of getting together, plants invented airmail. And the oldest trick, probably the original trick, is just to throw a bunch of pollen in the air and hope for the best. And it works okay if you've got a lot of relatives in the neighborhood, and grasses and pine trees, they still do it today. But it turns out to be more efficient to bribe something with wings to do the work for you. I mean, feet will do, but it's wings that really get the job done. And more than anything else, bees have adapted to be enthusiastic volunteers. They're good at carrying pollen, they're good at finding their way around, and good at forming opinions about which kind of flower to visit next. And that last bit turns out to be important, because pollination really only works when you leave a flower and go straight to one of its relatives. If there's 20 kinds of flowers around and you just sort of hop around, then the plants might as well go back to blowing in the wind. And bees are so dedicated to the gig that they have become what we call obligate pollen collectors. And if their larvae, if the baby bees don't get pollen to eat, they die. So bees have become the most reliable way for plants to make more plants. And that turns out to be important because plants are how the rest of us convert sunlight into not being dead. So with their laser focus on collecting pollen, bees have become one of the major threads in the web of life. Because there's a catch. For a mammal, and for most things really, not all plants are created equal. So, a loaf of bread, a jug of wine, and it could be a romantic evening, or it could be a harbinger of the pollinator apocalypse. And that's because out of all the plants that we regularly eat, the grasses that we use to make bread and other starchy things, and the grapes that we use to make wine, are among the very few that don't depend on insect pollination. They're old school, they use the wind. So you may have heard that 1 out of every 3 bites of food depends on pollinators. And people say that a lot, and it isn't wrong, but I think we can do better. I prefer to think of a sandwich. The crops that go into the bread will survive the end of pollinators. That's because they have something else in common. Most of them are grass. They're very starchy. They'll grow almost anywhere. Carbohydrates, when you think about it, are carbon and water. They're literally made out of air and rain and sunshine. That's it. And modern grass farming converts sunlight into calories on an industrial scale, and it's going to be okay. You know, our bodies are not going to run out of energy. But, and here's the catch, you can run a body on starch, but you can't build one. To build you need to make proteins. And building a protein requires elements that aren't present in the air or in the water. Ultimately, they come out of the soil. And for whatever reason, the plants that we rely on to get nutrients out of the dirt and into our bodies, or into a chicken or what have you, those rely on insect pollinators, mostly bees. So if the bees go, they're going to take the middle of your sandwich with them. Pretty much all of it. I should say there is one exception. Fish, especially ocean fish, don't really rely on pollinators. So a jug of wine and a dry fish sandwich. Coming soon to Dystopian Theater near you. So why is that a problem? Well, it's a problem because there aren't enough bees to go around. And the more we want them, the fewer there are. And this is what that looks like. There are only two things you need to know to read this map. The first is that the bees are colored blue. And the second is that the people who made this map didn't cheat. This isn't one of those annoying maps where the colors are scaled to make little differences look big. The yellow end of the scale here is 0. Yellow means that on average, if you go out during bloom season and set out bowl traps to attract the attention of passing bees, the number of bees that you catch per acre per day is nothing at all. So looking at the map, the first thing you'll notice is that bees love deserts, and that's true, but it's not great for farming. But the second thing is that this is not a map of habitat, not really. The yellow isn't a map of grass or forest or whatever. This is a map of human activity. It's a map of land clearance and pesticide use. The more intensively we farm, the fewer bees we leave behind. And it does get pretty bad. I've worked on farms in the Wenatchee Valley where every single bee was a hired hand brought in on a flatbed truck. If we ever learn to speak the waggle dance, they'll be eligible to join the UFW and strike for better working conditions. But without those commercial honeybees, the farmers just wouldn't have a crop. And the supply of honeybees, let's just say it's volatile. Some years are better than others, but none of them are really good. And the thing is, honeybees are new here. They're not native to the Americas. They were brought to the Pacific Northwest sometime after 1850 for honey production, and they weren't really managed for pollination until after the Second World War. So less than 100 years ago, there were enough wild bees already living in the landscape that we didn't even have to think about pollination. Now they've been replaced by contract labor. They're gone. So where did they go? Well, a lot of them died. Fortunately, not all of them, or Ben wouldn't have anything to talk about. But as it happens, I spent about 10 years looking for them before the pandemic. So I can tell you a lot of them came here. We found about 200 species of bees in the Puget Sound lowlands, and it turns out that a lot of them live in broken places, weedy places, marginal places, places around the edges of the spaces where people live and work. Places like this, some of you may recognize it. It's the edge of the parking lot, by the dumpsters, by the greenhouses at Jefferson Park. Now let's take a look at what's on this slope. There's several kinds of wildflowers here. At least 2 of them were in bloom when the Google Maps camera guy walked through the park. And over on the left, about 4 feet of the ground cover has slumped down into the parking lot, exposing some bare dirt. This is pretty good bee habitat. Now, before I hand this over to Ben, I want to pull it all together. Bees need 3 things to survive. Well, 4, but they need food and they need housing, right? But they also need room to move from one to the other because there's a lot of different bees and they each have their own preferences. The ones that live in the dirt here might be looking for food out on the golf course. And the ones that feed on, I think that's foxglove, the ones that feed on the foxglove might be nesting 100 yards away in the blackberry canes. And that's what we found. If you had the time to sit and watch and get a perfect count, a good-sized, healthy yard might support 40 species of bees. And if you scale out to like everything within walking distance, you might find 100 or more. So larger areas support more bees. We call them population reservoirs. They're large areas with food and housing and the space to bring them together. They're places where wild bees, native bees, have the resources and the room to survive, so that when the farms are healthy again, the bees will still be here. And in Seattle, we might as well just call the big ones parks. And that's why we're here. You guys may not know it yet, but you are already beekeepers. Not for honeybees, you don't need to wear the big white suits, but for all the native bees, the wild bees that keep our environment connected. And I want to be clear about this. We're not just guessing. In my last project, it took us almost 10 years to show about 200 species around Puget Sound. Now, there's a new project, the Washington Bee Atlas, and 3 years ago, we started working with Seattle Parks. And it takes a couple of years to identify what we find, so the very first results are just now starting to come in. And in that very first set of data, when we were still getting ourselves sorted out, we went into Seattle parks and found 50 species of bees. And that number is absolutely going up. We already have 2 more years of data that's still making its way through the system. And we started our 4th year just a few weeks ago. Seattle parks are full of bees. And the cool thing about this project is that almost every record also includes the plant it was visiting. It takes another year or so to process those, but starting next year, we won't just be able to tell you which bees hang out in which parks. We'll be able to tell you which flowers they visit when they get there. And we'll be able to do that park by park. So, for example, this is what we have for Magnuson Park. Each of those dots on the map can represent multiple bees. I've got one of them highlighted at the center top. And that's 30 records, at least 8 species from a single spot over by the off-leash area. And if you go across the entire park, you get that list on the right, 28 species so far. But I want to draw your attention to one species in particular. It's Andrena hippotes. Some people call it the orange-legged mining bee. It's a cool little thing, and it's rare, maybe threatened. I found one in South King County about 10 years ago. And it was the first time they'd been seen in Washington State in the last 60 years. And nobody else has seen one since. Until Ben found one in Magnuson Park. And then we found 4 more. So we know that they have what they need to survive. And now that we know they're there, we're going to work with you guys, starting with the gardeners at Magnuson, to make sure that they get to keep them. And that's why I say that you are all already beekeepers. Your choices keep them fed. Your actions keep them housed. The plants that you put in the ground, the holes you dig, the sand you pour, the mulch you put down, the pesticides that you perhaps choose not to use, you're shaping the spaces that sustain them. And you're already doing a pretty solid job. Like I said, Seattle parks are full of bees. But we do think that we can give you some pointers. We can help you to see the bees that are already there and be a little more mindful of the ways that the things that you do matter. And on that note, I'll hand it over to Ben.
Okay, so thank you, Will. So in this upcoming section, I'll be covering some bee basics to give everyone a crash course on how to identify bee habitat. So at first, we'll cover how to know a bee when you see one. And secondly, we'll go over the basics of bee biology. Then finally, take a look at different bee nesting habits along with some examples. And then finally, zoom back out to look at the bee habitats on a human scale. So you've now encountered a bug, and it looks like it could be a bee. How can we tell? So we could break it down into 2 steps, generally speaking. Step 1, you want to start broad, asking what order this insect is from. Now, it sounds very daunting, but thankfully, if it looks like a bee, your options are pretty much reduced to 2 orders. You got Hymenoptera, which are the bees and wasps, and Diptera, which are the flies. But for even more simplicity's sake, we'll just ask ourselves first, are we looking at a fly or are we not? And if we are not looking at a fly, we decided, then we can move on to the next step to decide whether we are looking at a bee or a wasp. So let's start with our first example right here. Flies have 2 wings, which are not really the norm among insects. Most insects actually have 4 wings. They also have prominent and large eyes that take up most of their head. And flies often have short antennae that appear as short little clubs. And so I hope those stripes did not fool you, because the 2 wings, short antenna, and large eyes points to this being a fly. It's a type of hoverfly. A really straightforward example, so we can move on to our second example. Now, the wings aren't really open and visible here, but if they're open, they would look like this. It's really subtle, but it actually has 4 wings, as I highlighted here. Bees actually zip their wings together to use as one big wing. And even if the wings aren't always fully visible, if that's the case, you could always fall back on the other two characteristics, such as the long antennae and the smaller eyes compared to flies. So this right here is not a fly. We could then move on to the next step. Now, I'm sure a lot of us here have the notion that bees are hairy, and that is actually true for the most part. Bees are on average hairier than wasps, and how hairy they are varies from species to species. And also, many bees have some kind of pollen carrying apparatus, often found with pollen on them. And like right here, you can see the pollen on the leg. And also, bodies of bees are composed of rounder shapes, giving them a very general rotund profile. So this example right here is pretty much the model example of a bee. It is a bumblebee. Then we move on to example 3. The wings aren't visible, but it has long antenna, smaller eyes, so it's not a fly. And although it's not as hairy as the previous example, you could see it on the metallic body in the middle there. It has a lot of fuzz on top of it. So it's still hairy. It has fuzz covering it. And right on the hind legs, you could also see it's carrying a lot of pollen. It also looks quite round, very composed of ovals all around. So this is actually a bee. It's a sweat bee, a green sweat bee from the genus Agapostemon. And one final example before we move on. Now, once again, the wings are folded up, but it has long antenna, smaller eyes, not a fly, not really that hairy. Maybe if you look really, really closely, but we're pushing it. There are barely noticeable fuzz in the middle there. And also, it is really gangly in shape. It doesn't really seem to be carrying any pollen on any pollen-carrying structures. So this is a wasp, a really common wasp around our area called a golden digger wasp. So to summarize, this is how you identify a fly. And there's one last trick that you could use that I would like to highlight is actually you could tell some fly species by just how they fly. They are described to be very uncanny how still they fly, like they're suspended in space. And I have a video right here showing you exactly what I mean. You can see this is a bee fly right here hovering around. This is not really slowed down. It just has a low frame rate, as you could see with that bee that just flown by. They have really different kind of ways that they fly. So another useful trick on the field. And then here's a summary on bees versus wasps. And I included a collage of a lot of examples for both. You could see exactly what I mean. The bees are very rotund, and then the wasps, they're sharper, longer, but quite variable in different shapes. And all of these are just generalizations for these groups of insects. They're useful in identifying things, but don't be afraid to bend them just a little bit, because as we could see, some examples are slightly, they kind of almost fit the bill. And so don't treat them as strict and hard rules, because as nature goes, generalizations are always going to butt up against exceptions. So bees visit flowers to mainly feed on the nectar and collect pollen. And they can have different shaped tongues, as you can see on these two pictures here. And the tongues actually limit what types of flowers they could feed on. Now, bees with longer tongues, like the bumblebee on the right, could actually reach deeper into flowers, while you got bees with shorter tongues, like the one on the left, they prefer shallower and wider open flowers, like daisies. And furthermore, bees could actually have preferences for what types of flowers they go on. So there are some bees who are specialists who don't really mind what flowers they choose they visit, while oligolectic bees are better at handling certain types of flowers over others. So they have flexibility, but they have preferences. While monolectic bees are the strict specialists. They're pretty much only visiting one type of flower. And one monolectic bee I like to highlight is called the death camas mining bee, Andrena astragali. Right here, it's on a death camas flower. Death camases are extremely poisonous, and to the point where even their pollen and nectar is actually lethal to bees if they ingest it. Not for this bee, though. It is made to consume poison. And so, and they only feed from exclusively this plant that no other bees like to collect pollen and nectar from. So they pretty much have this resource all to themselves. The benefits of being a specialist, I suppose. And aside from nectar, bees also collect a lot of pollen. And this is why female bees have these pollen carrying apparatuses I mentioned earlier. It's for transporting a lot of pollen. And these kind of structures come in two types. You got scopa and you got corbicula. Scopa are composed of really dense hairs. That's where they trap individual pollen grains in between those hairs. While corbicula, in contrast, has a very smooth middle surface that is surrounded with long hairs. The pollen is actually carried in the form of a wet paste, where they pretty much slap it on the flat middle of their corbicula and hold it in with the hairs surrounding it. And this kind of structure is also sometimes called a pollen basket, which is a term I'm sure some of you have came across. And they can be found on different parts of a bee, depending on the group. Now, for a lot of them, it would be on the leg, like this right here. This longhorn bee has a scopa on its hind leg. Meanwhile, this leafcutter bee has a scopa on the underside of its body. And the bumblebee right here has a corbicula that has a giant glob of pollen stuck to its back leg. And the final example in the lower right, you can see it has a lot of pollen on the scopa on the back leg. But actually, if you look really closely, it also has a bit of pollen under its wing. So it actually has a corbicula on the back. So some bees could actually have both. Now, why do the bees go out of their way to harvest all this pollen? As previously briefly mentioned, that's because pollen is actually baby food for bees. All the pollen is collected and put into one big pile inside of their nest, where the bee lays her eggs on top of it. And then the egg will hatch into a larva. The larva will consume the pollen until it's all gone, turn into a pupa, and eventually a new adult bee will emerge, restarting the whole cycle again. So now that we've established all the basics, we can move on to the main topic of how bees nest. So the nesting habitat of bees could generally be split into three categories. You got the tube nesting bees, the cavity nesting bees, and the ground nesting bees. Starting with the tube nesting bees, they like to construct their nests inside of tubes or tunnels. The bee hotels, like the one on the left here we put out, actually are mainly catering to these type of bees. It provides nesting opportunity in the form of pre-existing hollow tubes. And one of the most common occupants of these bee hotels are the mason bees right here, Osmia, who got their name from their use of mud to section off and seal their nest tubes off, like right here. This photo is the inside contents of one of these tubes. The white is actually the silk that the bee, when it pupates, spin around the tube cells. And the brown in between where the arrows are pointing to, those are the little mud caps that the mother bee has laid down. And in nature, because bee hotels are not really natural occurring, at least the human-made ones are not, but they actually live inside of larvae holes, beetles that bore into the wood. And when they emerge from those holes, leaving that tube behind, the mason bees use those hollow tubes inside of logs to nest in. And another very common tube nesting bee you'll encounter is the small carpenter bee, Serratina. They are really small, metallic color bees, no more than half an inch long. And being so small, they're actually able to make use of broken plant stems as a nesting tube, constructing their nest by digging into the middle, the soft middle of the plant stem. As for the cavity nesting bees, one of our local representatives are the bumblebees, and mainly, pretty much only the bumblebees. Now, like this example here, is a black-tailed bumblebee, Bombus melanopygus, who built her nest inside of a birdhouse. But they also like to build colonies inside of any cavity they take a liking to, like old rodent burrows, tree hollows, and birdhouses like here. And aside from bumblebees, not many bees fall under this category, but they are really prominent because they are social. And so it's mainly the social bees who are very defensive of their territory because they have more to lose. They have a whole colony going on. So they're more likely to be defensive when disturbed. That's why they're also the ones that always end up brought to our attention. And the final category, also the largest category, are the ground nesting bees, which are the 70% of all bee species. All fall under this category, which is a fact that often surprises a lot of people. And I'll be covering numerous examples coming up. One of the most common ground nesting bees you'll encounter are the orange-legged furrow bees, Halictus rubicundus. It is often easy to spot their burrows because they often leave behind a loose tumulus, this surrounding pile of dirt around their nest hole, because they just kick their dirt out as they're digging. And they also like to construct their nests under base of plants sometimes, like this burrow right here that you can see that's concealed by tufts of grass. Generally, these bees like well-drained sandy substrate, although they're not overall too picky, and that explains why they're so common. Up next, we have the prunus mining bee, Andrina prunorum. Now, this bee right here is all loaded up with pollen, about to enter her burrow, and this individual right here specifically built her nest in some really hard and compact soil right here. In fact, this picture was taken in a crevice along a sidewalk. May not be the first place you'll think to look for a bee nest, but bees are actually really hardy and could be nested in really unexpected places. Up next, this is a picture of a sand wall at a beach, and you can see all these little white tubes sticking out and exposed by erosion. These are actually the old burrows of plaster bees. Many bees actually produce a secretion that they apply on the burrow walls when they dig their nest. And so it pretty much functions as interior paint for bees. And in plaster bees, this substance actually resembles plastic when it dries, and it actually allows their burrows to be more water resistant. And this water resistant property allows their burrows, for some plaster bees, to like to build their burrows inside of very wet soil. Now, nesting habits could vary a lot even among relatives. And so up next, I'm going to showcase a whole tribe of closely related bees known as the digger bees. And they have a wide range of different nesting habits, starting with the most common digger bee you're going to find here in Seattle, the Pacific digger bee right here. Now, they do not deviate too much from the norm as far as ground nesting bees go, though they do have a preference to habitat with an incline, contrasting with the first two examples, the mining bee and furrow bee that I showcased earlier, who actually prefer flatter ground. And up next, on dunes and beachside cliffs, you often find Pacific digger bees, or Pacific dune digger bees, not Pacific digger bees, that's the previous one, which are Habropoda miserabilis. Their whole name pretty much gives their entire game away. They're digger bees that like to nest in sand. That's their common name. Their scientific name, if you let me to go on a tangent, Habropoda means beautiful foot, and miserabilis means miserable. Now, the miserable bee with beautiful feet. I don't know who named this, but I don't know their logic. Now, up next, we have the final digger bee here, is the bumblebee-like digger bee, Anthophora bomboides. They build their nests with this distinct structure right here, a wall of dirt forming a chimney that extends out from their burrows. We call these structures turrets, and what function do these turrets serve? They're actually a defensive measure, but against what? Now, against these guys, because bee nests attract attention of a lot of other insects, such as cuckoo bees and parasitoids. And these guys have one goal, is to sneak their eggs inside of nests of bees and to either take advantage of pollen stockpiles or consuming the bee larva itself. And so because of this, they actually like to hang around places where a lot of bees live. And so to us, they actually make them really useful. It actually makes them really useful indicators telling us that bees nest here. And they're also an indicator for bee population health too, because it suggests that the bees in this area are doing so well, a whole food chain is built on top of them. Now, let's start with the cuckoo bees. They are a really diverse bunch. On the left here, the left 4 photos. They're also sometimes called kleptoparasitic bees. Kleptoparasite means parasites that steal. But what do they steal? They actually steal the pollen of other bees. So instead of directly collecting pollen for themselves, they actually are after the pollen stores that other bees collected inside of their nest. So what they do is they sneak into the nest of other bees, pretty much like a cuckoo bird, and they lay their egg on the pollen. And so when their offspring hatches, they could just claim the pollen to themselves. And so with a lifestyle like this, they often don't really need to collect pollen and could be quite hairless, as you could see on the example right here, here, here. This one has like really short fuzz. And instead of being hairy, they're often opting more for defense, to have harder exoskeletons to better defend themselves against the host bee, because I'm not sure they're not too thrilled if they ever catch the cuckoo bee. The first species, and well, the only species I'd like to highlight today, is the blood bee, Sphecodes, named after their eye-catching red color they have on their body. You could see the one on the left here is surveying the area, hovering around dirt. You could actually often see these bees flying in a very distinct way, unusual for bees, because they have this really meandering flight path, like they're scanning for, because they are scanning for host burrows to sneak into. And the other photo is a very awkward standoff between the host, who is in its home, plugging up the burrow entrance. Up next, we have the parasitoids of bees, which in this example, I choose the bee fly, which is a whole family of flies. Now, they look quite harmless because to us, they are, but for bees, they're actually little bomber planes that rain down eggs. So what they do is actually they hover around bee nesting sites to wait for an opportunity to arise. Then she'll find an unguarded bee nest and swoop in to shoot eggs straight into the burrow hole. And the maggots then hatch from the egg, will feed on the developing bee larva, which is why they're characterized as parasitoids. And it is believed that the turrets, like the turrets that bees build, like bumblebee digger bees that I covered earlier, are actually a defensive measure against these flies in their egg bombing runs to block their eggs that they're launching. And I have here a video of what I mean exactly about egg launching. You can see it hovering right here, and that tiny little speck that it's shooting there, if you missed it, just in case, I'll play it again right about now. Launching straight into the burrow of a bee. So we looked at how bee nests look up when up close. Now let's look at these bee habitats on a human scale. So for example, we'll use this grass field adjacent to the north parking lot of Discovery Park as an example. And to identify a bee habitat, you want to identify some things that the bees need. For example, the food source and the housing, as Will briefly touched on earlier. So along this pathway next to that open field, you can see there's a lot of trees, and these trees all bloom during spring, providing willow flowers and maple flowers for all the different types of bees. Willow and maple blossoms are actually a staple food source for a lot of different species of bees, especially the willows, which are a preferred food source for a lot of early season mining bees. As for housing, although grasses form a really dense root mat, which becomes a barrier for ground nesting bees, often grassy fields aren't uniform, and you'll find a bare patch of exposed soil. And it's these bare patches of exposed soil that are perfect nesting ground for bees. So during mid-April of last year, I actually sampled this exact location for the Washington Bee Atlas, and I found a whole community of bees living on these exposed patches of dirt. So we have the previously mentioned prunus mining bee, as well as 2 other species of mining bees, and even a blood bee. And these are the ones that I caught, but the abundance of mining bees in this specific site would suggest that their cuckoos, a different type of bee called a nomad bee, would also be present, while the blood bee right here would suggest that their hosts, the sweat bees, are present. So that makes potentially at least 6 species in just this one small part of the park, this one field of the park, which is pretty impressive. Now, as Will previously mentioned, you're all natural beekeepers without knowing, and there's a lot of things that you do that affect the bees, creating or potentially even destroying bee habitat, each with their own set of trade-offs. So those examples are mulching, planting, weeding plants, applying pesticides, soil amendments, and irrigation, just to highlight a few key ones. Mulching, for example, creates a barrier between the dirt and the sky. It's really effective at preventing weeds from growing, giving all the other plants a chance to establish, but it also creates an impassable barrier for ground nesting bees. And what we choose to plant while designing a landscape also have great effects on bees. You got ground covering plants, for example, like some grasses. Some grasses form a dense root mat that block the passage of bees the same way that mulch does. And so it's important to balance that ground cover with patches of bare earth, because bees, as a lot of us have already said, need dirt. We also unintentionally, while selecting for specific types of flowers to plant, select for the bees that like those plants. So there's another factor in choosing what to plant. And one final one I want to highlight is weeding. Now, I'm sure Himalayan blackberry, really common target of weeding efforts. That's because of how prevalent they are, right? And clearing and cutting them will open up a lot of nesting habitat that would be beneficial for bees. For example, just clearing them away opens up open ground for ground nesting bees, but also tube nesting bees could use those discarded stems of blackberries to nest in, like the small carpenter bee that I mentioned earlier. But in doing so, on the flip side, you're also removing a really big, really present food source for other bees, because a lot of our native bees actually love to feed on blackberry blossoms. And so, now we're nearing the end. Let's all tie this back to where we started in Jefferson Park. Now, we learned a lot about bee habitats. Now, so for a question here, where would we find bees nesting here in this specific location? Would it be an A, B, or C? Now, I don't think this is interactive, so I'll just let it sit for a few seconds, think, and then go over it a few answers. So, A has loose earth with an incline, while B has more compact and flat dirt. Right now it's a bit wet, but later on in the season, once it dries up a bit, the moss will die back and it becomes more habitable for bees. So A and B are actually both really good nesting habitat for ground nesting bees, while C has an abundance of broken blackberry stems, which is ideal environment for tube nesting bees like the carpenter bee I mentioned earlier. So the answer is actually all of the above. In fact, the variety is what makes this a good habitat. So at the end, I just want to acknowledge all these people. Special thanks to them, because all these wonderful photos you see throughout this talk are from them. And so now I'm at the end of my part. I will hand it back to Tony.
Do I hang out with these guys? Yeah, I learned a few things. I can't remember exactly what I learned today, but I mean, I learned a lot of things just doing this webinar. Couple things I want to stress. Will had mentioned that it's really important to have bees go from flower to flower of the same species. That's something that's really important if you're thinking about doing that in your yard. You want to plant a lot of the same thing in bunches. It really is, it comes down to location. So, you know, if they find the flower that they need right next door, they're going to walk to it instead of flying. Flying is dangerous, as you have probably figured out that the world of insects is can be dangerous. So, and if bees can walk and save energy and avoid danger, they will do so. So that's one other thing you could do if you consider doing this in your yard. And then another thing that I want to stress is that going back to your yard, you want to consider, and I'm not sure how you do this in parks, but generally we recommend 10 to 20% of your property, if you're going to do any planting, that you plan for 10 to 20% of bare ground, of dirt. And a lot of times if you're you know experienced planners, you already have that in your yard. You already have an area that doesn't do anything. You know, humans kind of want to kind of control everything, so they try to take an area that's not doing anything and damn it, I'm going to make it do something. But a lot of times, you're going to basically build something by doing nothing. So I just wanted to bring this point, stress those points a little bit.
Hey, thank you so much. Okay, that is the end of your presentation, right? You
Yeah.
guys aren't going back and
Yeah.
forth more. Okay, perfect. I just wanted to be sure before saying saying thank you at the conclusion. That was fantastic. You guys are incredible. I learned so much, and it was such an entertaining presentation as well. We'll hand it over to Cece so that we can get everybody credit, and then we'll go to Q&A.
Yeah, that was so good. Thank you guys so much for all of that. All right, I'm going to share my slide here. This will be the last one of the day. And we have our code word here, bees. Again, you can click the link in the chat. You can use the QR code if you'd like. Get your credits. The code word is bees. I think Steve is doing our Q&A for this round. I'm sure we have a lot
I
of
think
really
I'll
good
just hop in
questions.
because there's a bunch of questions.
Yeah.
Yeah, I'll ditto that. This was incredibly entertaining and incredibly educational. So I'll just ask the question, and the three of you can decide who wants to answer. But the first question is: there's a significant movement within many ecologists' centers away from honeybees due to their non-nativeness and the perception that they're in competition with native bees. Do you have thoughts or comments on this? Is there room for both honeybees and native bees to coexist?
I don't think we have enough time for all of my thoughts and comments on that, but the short version is, yeah, there's room for both native bees and honeybees in the same way that there's room for native birds and chickens. And honeybees are an agriculturally managed species, and they do compete with native bees in the wild. So as long as we keep that separation in mind and make our priorities according to that, then it's all good.
I'd like to add that really it's about responsible beekeeping. So if you're transporting bees around in semis, that's not responsible in our opinion. That's not how the bees are not, the honeybees that they're using are not, they're hired help and they're not getting fed well. So that's another thing to consider.
Okay. A number of questions came up around this point because for us gardeners, like mulching is like sacred. And so we're concerned that how can we make this wanting to mulch, which is good for the plants, and yet create habitat for the bees. Let's see, let me get one that's, how would y'all suggest keeping exposed soil around for ground nesting bees? Some people consider it unsightly. If you want to comment further on that.
I mean, the easiest way is to find the places that are unsightly and leave them alone. The next best, I would say, if you're using if you're putting down a layer of mulch or some other barrier, try to think ahead a few years and use something that will break down over time, and then sort of open up more space once the plants around them are a little better established. And yeah, that can go for that's another conversation that can go for a long time. But those are the first two things that come to mind.
I would add, you can always add signage and say this is a native lawn and it might not look pretty, but it's pretty for bees or whatever, something like that. So signage helps.
I love it. There's a request at some point for a link for Bee Atlas research. People are interested in being able to access that site. I think that just came up. Okay, that's in the chat. Another question is, I've heard that many of the veggies we grow in gardens, like tomatoes and peppers, are not pollinated by honeybees, but instead rely on native bees for fertilization. Is this true? Do you know any examples of vegetables that get pollinated or rely heavily on native bees?
Yes, it's true. The pretty much all of the plants in the Solanaceae, so tomatoes, potatoes, tomatillos, they're all, most or all are pollinated with a technique called buzz pollination. The pollen is kind of packed into a little mechanical box that's in the middle of the flower, and the bees actually have to land on the flower, grab that little box, and shake it. And the way they shake it is they unhook their wing muscles and vibrate their from the wings, and they vibrate the wing muscles really fast without actually moving their wings. And if you listen, they're playing a specific musical note, and it's really close to middle C. And if you've seen the video of Galloping Gertie, that suspension bridge where the wind shook it and shook it and shook it until eventually it fell apart, well, the bees are doing that to the tomato flowers. So they shake it until the little pollen packet, which is under tension, just goes poof, and you get this cloud of pollen. It's kind of cool.
Wow, no, that's very cool.
And I'd also like to add, there are aside from buzz pollination, certain flower structures, like for example peas or the legumes, they sometimes require more strength to open them up. So smaller species of bees can't access some of these flowers and only bigger bees are able to pry them open. That is one example. And alfalfa, which is that a legume? I think that is a legume, right?
Yeah.
Alfalfa, when bees try to pollinate them, they actually have a trap, I think, that springs when bees try to land on them that whack the pollen onto the bees. And certain bees don't like to get whacked in the face, which I think honeybees aren't, right? Could back me up here, Will.
Yeah.
Oh,
Yeah,
good.
that's why the little leafcutter bees are so effective at pollinating alfalfa. They have armored heads, and they just don't even notice when the flowers smack them like that.
And since we're talking flowers of vegetable plants, another thing to know is that if you can leave things like brassicas or arugula, let them bolt. and they are great sources for of food for all types of pollinators. And oregano is a really good one because it's a perennial. You plant it once, it really doesn't taste. It doesn't taste bolty once it does the flowers, and it's perennial, so it grows all the time, and it'll have lots of bees on them. So oregano and thyme are two plants you should consider.
Cool. I like how neglect is a power here. That actually by leaving something, you actually benefit the bees. Another person had a question about how do these little tiny digger bees dig through really dense, hard packed soil? How do they do it?
Jaws.
So I guess
They have really strong jaws. That's the short version. I think Ben can give more detail on that.
yeah, I guess strong jaws and I guess the shape of their mandibles also play a part into it. If you look at mining bees, they have really pointy jaws that allow them to chip it like a pickaxe. Will told me.
I love it. One more question. Where can we find more specific information about the bee survey at Magnuson Park that Will P. is involved in? And great presentation.
That hasn't. So we're still in the process of getting that published. And okay, that's misleading. We're not doing a formal publication. We're still in the process of getting the website up and running with the Washington State data. So if you Google Melliflora, I'll put that name in the chat. You'll get a really cool website for browsing the plant-pollinator interaction data in Oregon. The Washington version of that is not ready for prime time yet, but in the next few months it should come up. So
Excellent. I think I am at the bottom of my list. I think you should mark it like half your quotes. You should mark it as T-shirts or bumper stickers because they're extremely witty and fun. So, anyway, thank you so much.
oh, thank you all for having us.
Thank you.
Oh, I was so happy to hear about the bees, and I also love that you guys are all right here in Seattle, and talking about our Seattle parks and habitat for pollinators here in Seattle Gardens, which is super applicable for, those of us here who are putting on the City of Seattle IPM webinar. It's a great way to finish our series today. I just want to thank you guys again. The three of you from the Native Bee Society, Tony Dickey, Will Peterman, and Ben Lee, thank you, thank you. I also want to give a warm, heartfelt thank you to our other two speakers today, Glenn Kohler and Brittany Jones, as well as all of the other speakers that joined us this year from our previous two webinars. Okay, what else do I have in my notes? I know I want to thank our entire committee. This is our IPM webinar committee over here on the right-hand side. There's Bridget Kelsch from Seattle Parks and Rec as our chair. There's me from Seattle Public Utilities, Cecilia Miller from Seattle City Light, Eric Sterner from Seattle Parks and Rec, Joel Ferrero from Seattle City Light, Steve Sosi from Seattle Center, and Mark Malone also from Seattle Parks and Rec. You can see we are an interdepartmental team that joins together to host and plan these webinars. I want to let you know that when you leave the webinar today, WebEx will automatically direct you to a feedback survey. Please, if you have the time, if you can fill out the survey, let us know your thoughts. It really does help us plan future events. So we can take all of those comments into account when we're planning our webinar series for next year. Once again, this was the final webinar for this year, and so stay tuned. We will come back next year in the winter of 2027 for another IPM research series. Thank you so much and enjoy the rest of your day. And happy spring. Came back. Thanks, guys.
I know.
Thank you.